I'll ask the audience, see if they can hear a reverb or if there's any problems with the sound. Usually do that before we get started anyway. Wait for some people to just hop in and tell me.
No.
Sound check. So we got China's in the audience. How is the sound, audience? Is the sound? You might want to say something just so they can hear you. See if you sound okay. He's probably refreshing. I'll see if he comes back. He should come back pretty soon. Hey guys, how's it going? Might as well chat while waiting for him to come back. All right, so yeah, they say the
Somehow I
sound.
think the page crashed.
Yeah, I think it's on your end. You seem to have it says you have a weak
What?
connection. Because yeah, the people in the audience say my sound's fine, so I don't know. I think it's on your end. But as long as it's tolerable, then
Okay.
it should be good. You can just,
It's actually, the audio is better now than it was before.
oh, that's good. All right.
So there's a little bit of a reverb, but it's I can easily hear you. So
Okay, and if it crashes again, you can just press the refresh button because it'll be the exact same website and should work fine. All right, so Johanan, is that how you pronounce your name?
yes.
Thanks for coming on. I really appreciate you taking the time to have a conversation with me. You're an idealist, is that correct? You believe that everything is fundamentally mental.
Yeah.
All right, I'm an atheist, by which I mean I believe
Yeah.
there's no reason to believe in a God. Could you tell me some of the reasons you believe that we have to justify the belief that the universe is idealistic or fundamentally mental? And I can tell you my position on those reasons, and then I'd like to hear your
Okay.
thoughts on my position.
So the first one is from physics, fundamental physics, and they're trying to unify quantum mechanics with relativity now.
There's no
General
reason to
relativity,
believe in a
that is.
God.
They've
Could you tell
already
me
met
some of
with
the reasons
special
you believe
relativity
that we have
a long
to
time ago.
justify the
But
belief that the universe is?
the conclusion they're coming to is that in order to do this, space-time has to be emergent, and specifically, they've discovered in the last 4 or 5 years that it is emergent from quantum entanglement. So, quantum entanglement, of course, being the phenomenon where you have two particles sharing the same quantum state, and you separate them at vast distances, and you affect one, and the other one changes instantly. So, what's actually going on is that we're calling space-time, which is the distance between you and where do you live, by the way?
Minnesota.
Okay, I'm in Wisconsin. So you're in Minnesota, I'm in Wisconsin, and we, normally you have to travel a bunch of hours to drive there. But in reality, in quantum, the findings in quantum gravity are saying is that distance is a construction of quantum entanglement. And of course, when we're talking about this, they're saying that space is actually an illusion. Now, that may sound astonishing. And if you heard a random Joe Blow on the street say it, you'd say, well, that's crazy. But these are our top-level physicists saying this, and not just one or two of them, but virtually the entire quantum gravity field right now is saying that space is an illusion or is emergent. It doesn't fundamentally exist. And then it emerges out of these entanglement links, entangled quantum information. So, of course, when you have space being a construction, that means everything that occupies the space also has to be a construction, such as matter and energy, or what we think of as matter and energy. And then, if that's the case, then everything that we're calling physical in space-time sense, not necessarily within the realm of physics sense, has emergent. It is not fundamental. And so the only thing that left is information, specifically quantum information, and then everything emerges out of that. Now, that's consensus physics in the field of quantum gravity right now. Now, of course, that gives you immaterialism, but immaterialism isn't exactly the same thing as idealism. Idealism is a subset of immaterialism, right?
All right, well, one second.
One just said the world's immaterial, but doesn't say what the substance that.
So I'm familiar with emergent spacetime. I do follow the work of Nima Arkani-Hammad and Sean Carroll. So I do grant emergent spacetime, but emergent spacetime does not say things are non-physical. Most physicists are atheists and materialists, and they grant emergent spacetime, but they say it's still within the philosophical concept of materialism. All of the particle duality of like waves and particles and things is still material in the philosophical sense.
Well, that doesn't make sense, though, because, I mean, well, it depends what you mean by material. What are we defining material as exactly here?
I'm using the philosophical sense, so the things that we can verify.
What sense is that? Because within philosophy, there are different ways of defining materialism, and the most common way, this is both with Kant, Immanuel Kant does this, as well as, this is kind of the common sense view, is that matter is something that occupies space-time. Like, for example, you're sitting in your sofa there. If your sofa had no spatial extension, it wouldn't make much sense to call it a piece of matter, would it?
Again, the definition of materialism I'm using is the one that most philosophers use, which is just materialism is the stuff we can verify and the stuff that can extend from that stuff that we can verify. So it has nothing to do with space-time, because we know space-time is not fundamental and there is more natural material stuff beyond
okay.
space-time.
So it has to do with what you're grasping at basically is that it's within the realm of science, right?
Essentially.
Okay, well, that's kind of funny, because what you're defining as materialism then is what I'm defining as naturalism. And the irony of this, despite being a theist, I also identify as a naturalist. So if you're calling it matter, now, materialism and idealism are thought to be different contradictory branch views, right?
Yeah.
Okay, one's all made of matter, the other one's all made of mind. But those are using the definitions where they are mutually contradictory. Now, if you were to redefine matter or define it, what I would thought it was is defined as being in space-time, but if you're to define it differently than that, as it being something that we can access through science, then I would simply say that you're equating that with naturalism, which, if you want to do that, that's fine by me, just that it no longer contradicts my definition of what idealism is, and it no longer contradicts the world being ideal in that sense. So,
okay, you would need to
basically, you have a situation where what you call a idealist materialist, which sounds like an oxymoron, but we realize we're simply playing language games with words at that point, and it's
right. So you would have to explain what you mean, because from my understanding, the philosophical definition of idealism and materialism, they are mutually exclusive. So my position is the materialist naturalist position, where matter is fundamental and matter exists everywhere, and idealism is just false. There is no such thing as a conscious ontology, essentially. It's just an emergent property. So from my position, I am a materialist.
Okay, this is actually interesting, because it ties into, well, firstly, let me finish the physics argument. But then we're going to jump into the epistemology argument, because if you're defining materialism in that sense, it's actually very ironic, because from an epistemic point of view, the only way you can get science off the ground, which is the study of an external world through the senses, is if idealism is true. But we'll get to that in a second.
Well, actually, let's start with that, because I grant emergent spacetime. Most physicists grant emergent spacetime, but most physicists are atheist materialists.
Yeah, well, I was going to combine emergent spacetime with Tononi's. This is also the most popular view in cognitive science. It's not. It has implications on emergent spacetime, which few people are exploring, but by itself, it's
the IIT. Yeah,
call it integrated information theory of Giulio Tononi. You've heard of this?
It's not the most common perspective in cognitive science. The most cognitive position in cognitive science.
It's the most. Okay, I shouldn't say the most common perspective. It's not. I shouldn't say the most common, because there's a plurality of views. It has a plurality position. The other ones, they're not. They're in a class of theories essentially, but they're not like the most. This is the most probably the one with the has like probably a plurality when it comes to an individual distinct theory rather than a class of theories, as far as I know anyway.
As far as
and it's
I'm
kind of
aware,
commonsensical too, because it simply says,
if I can find it. The most common held position in cognitive science is physicalism and materialism. I actually have a quote from a guy who was on.
well, no, I'm saying past that.
What do you
When
mean
you
by
go to
past that?
individual theories of like what's I mean, because there are some people who are. What I'm saying is there are integrated information theorists who are materialists. Most integrated information theorists happen to be materialists as well.
Yeah.
So it gets tricky when you talk about this, because you can have integrated information theory without materialism, but at the same time, most integrated information theorists also happen to be materialists.
Yeah,
But
the
it's the
vast majority of
specifics
cognitive
of the
science
science
rejects
of integrated
idealism.
information theory that I want to get into.
Most cognitive
Yes,
scientists
I know,
reject
but what I'm getting
idealism.
at is I'm forgetting their. What I'm saying is I'm forgetting forget their specific views at the moment and look at the specific science they're talking about. And when we combine that science with the emergent spacetime science, what we see is that spacetime emerges from consciousness. That consciousness is actually identical with quantum entanglement, as per Giulio Tononi actually in his paper on this, as a footnote where he mentions that entanglement is identical with integrated information because it's treating two entities as fundamentally the same thing.
Right, I understand his theory, but his theory is widely rejected by most people in both fields who are familiar with both fields. So, I mean, it's a nice interpretation, but there's no evidence to support it.
That's not what I've heard. That's not what I've heard though. Is that it's widely accepted now.
Well, no, integrated information theory as a model to map information is widely accepted as a thing. There's lots of criticisms of it. It's not used as a majority of people in the field. But his interpretation that it's the same as
that's because there is no distinct within cognitive science. There is no one theory at this point has like a large. It's widely up in the air, is what I'm saying.
Right, but the majority all hold to
which theory
materialist information is a
accurate.
physical thing. So, I mean, there's lots of different versions of them, but they
right.
all
I know,
to,
but what I'm saying is
but that's a different
when
topic.
you say
I'm talking about the physics part, the connection between the IIT and physics, that emergence and entanglement and consciousness are the same, is widely rejected by pretty much everybody in both fields. That is rejected.
Well, the question is why that would be the case, though. Then, because your audio still there?
Yes, I can still hear you.
Okay, yeah. Well, the question would be then why would they do that? Because there's no reason to assume that the information in your brain is conscious, and theoretically, the artificial intelligence community, for example, thinks that we could eventually one day instantiate a mind on a computer, right?
Yeah.
Whether or not that's possible, that's their large view. So it's possible in a brain, and in theory, at least, it may be possible in a computer. There are some issues with that regarding Searle's Chinese room and so on, but they believe that it would be possible inside of a computer as well. And so, but the point is if it's possible in both those systems, what makes the information beneath space-time so special that it is excluded from being conscious, whereas the information in your brain is conscious, or in a computer is conscious, right?
Well, it's just different forms of information. Information can come in different forms. There's no requirement that it's conscious in any way.
Right, but there's the thing with information, because then you're getting sort of a dualism, which is kind of intriguing to me, because there's now a information is simply information. It's a bit or a one or a zero or something, right?
Right, but different things can process information differently. Information is usually thought of as a physical thing. Like the consensus in physics right now is that information is physical. It is a physical thing. It's a physical property of matter, or a description of matter.
Yeah, but if you're defining physical as within physics, I have no problem with that, because I would use the same definition. But I would just also say that via Hempel's dilemma, that distinction is kind of basically it's simply playing games with semantics at that point. It's like, let's just dispense with the words physical altogether. Physical, natural, material, all of this, it's simply meaningless semantics. Let's do the science itself. And model the world in terms of science.
So when I'm using the term physical, I mean
Because
as in
it's,
like
you see
physical.
what I'm saying here?
Well, yes, but I'm using the term specifically to be an antithesis to your position. So I'm using it in the same way that Landauer's position that information is literally a physical thing that is a property of the universe. There is no mental property to it at all. It's just a like spin
Okay,
or energy.
so why would it need to be okay, I think I see where this is going, and if this is going right, I'm going to have to look at what exactly is meant by a physical property in a moment. But what I would ask then is why it is not possible for mental substances or why can't mental things also be what we're studying in physics? What makes that intrinsically impossible?
They could be. There's just no reason for them, no reason to believe that is the case.
Why are those two mutually exclusive?
So right now,
your audio is a little bit slowing down. Repeat that.
Right now in physics, we use testable predictions using the information is physical theory to be able to make useful descriptions of the universe. We have no need to employ idealism or some other ontology in addition to that, and so we usually reject it simply by the fact that it adds nothing to the theory. So right now, the best evidence we have is that information is a physical thing and not a mental thing, simply because the physical thing makes the predictions and the mental thing has not added any predictions that we would otherwise have.
Okay, so what you're saying is that we can make predictions with the information, and that leads to conclusions that we can test and so on. But why would that exclude? Why would that mean that the stuff that we're measuring those predictions in terms of is mental, not mental in nature?
So the way we
actually, there is one direct experiment that was done just this year that would actually contradict that, I believe. So.
I believe the consensus is still that is not the case. So I'm not sure which one you're referring to, but believe the consensus in physics is still.
No. What I'm saying is okay. Now that's an interesting.
I haven't answered your question yet. You asked a question. I wanted to answer it. So,
sure.
Why do we believe that it's physical and not idealistic? Well, the reason is because when we have an explanation, some phenomenon we don't know, and we're going to try to explain it, we posit a hypothesis. We say if information is material, we're going to use that assumption to make predictions and say, using those predictions, we estimate this is going to be the result. And we do the test, and we're like, yep, that's the result. We get the result. So right now we're going to say that is evidence that our hypothesis that information is physical is correct. It's not proof. It could be idealistic. It could be otherwise. But in order to justify the alternative conclusions that it's idealistic, idealism has to make a different prediction. So that's to say, we're going to assume that information is idealistic. Here's a prediction we're going to make, and then that prediction comes true, or we find out it's correct, then that's evidence it's idealistic. But right now, the vast majority of the evidence is on the materialistic side. We assume it's materialistic, and there is no external ideology.
There is no evidence that contradicts.
Right, and there's no evidence that contradicts the.
There isn't any experiment that contradicts.
Right, that's true of all of the interpretations of physics. There isn't an experiment.
But that would also mean materialism, though. That would mean your definition of materialism. There's nothing that would then spell that out as being the correct one. If there's two hypotheses and there are no experiments to distinguish them, there is no reason to assume one over the other. But that also includes materialism. Now, as it turns out, there is an experiment, which I'll get to in a bit, that.
Right. So anytime we posit a hypothesis, there's always going to be, due to the problem of underdetermination, there's always infinitely many ways to explain anything. Always. So like if we say, what knocked over that glass?
Right, but if that's the case, and the infinite number of ways to explain them are indistinguishable, then why pick one of those particular ones and run with it and say that this is therefore likely the best one, which would be like, say, the materialist one?
Whichever one we can use to make future testable predictions first is the one that we choose.
Right. The point is that they all do that.
No.
The idealist one fits all the exact same predictions.
No. Right. So you have to start with one. Somebody comes up with an idea, and that idea is then used to make future testable predictions. Whichever one comes up with the idea first and that model can be used to make future testable predictions before anyone else, that's the one we accept. So like Newtonian mechanics was used to make future testable predictions.
Yeah, but those ones are not. So Newtonian mechanics didn't distinguish between idealism and materialism, though. It talked about masses were gravitating to each other and masses that were moving via
Right. So my
mechanical
position
force and
is
so
that
on.
like when Newtonian mechanics made predictions and we accepted it, there's lots of other hypotheses out there, but they didn't make predictions. Newtonian mechanics did. It was wrong ultimately because we know general relativity overthrew
Right, but
Newtonian
Newtonian
mechanics.
mechanics doesn't distinguish.
That's not the point.
Right, correct. But the problem is that Newtonian mechanics doesn't distinguish between whether the masses that are gravitating or interacting mechanically are either material or mental constructs.
Right. I'm not saying it does.
They could be either or both, and it
Right.
doesn't say which.
I'm not saying it does. I'm using this as an example. So this applies to any scientific hypothesis ever. So we have some unknown that we can't explain. And then a bunch of different people come up with different ideas to try and explain it. Now, whoever comes up with the idea first that can be used to make predictions, that's the one we accept. That's it. That we accept that one over all of the others, even if all of the others can post hoc.
Then show me.
Even if all of the others can post hoc explain the same evidence, we don't accept those. We accept the one that's first until other ones can come along and make more predictions. And right now, the hypothesis
That's fine. That's fine. But if that's the case, and I took a physics major in college. I have a physics degree, and I've seen all the physics theories, and I've not seen one which says that the world is a material construct. In fact, they don't even talk about it that way. They don't use the language of materialism. They use the language of, masses or velocities or spins, etc. It doesn't show up in the theories anywhere. So I'm curious which theory it is that you're saying is making the predictions that has materialism in it.
Landauer's principle of physical. So it's just saying that the physical principle pertaining to the lower theoretical limit of energy consumption of computation, and information is just a physical property like the universe, just like all of the others. It doesn't exclude idealism, but it doesn't require it. So it uses the assumption that the world is physical, natural, material, if you want to put it that way, and it just uses predictions, and that's what we go with.
Right, but I think that my form of idealism is fully compatible. It's not just fully compatible with science. It's saying that what we're seeing in science is mental constructs. So if that's the case, then it's fully compatible with naturalism. It doesn't contradict Landauer's principle in that sense.
All of the theories in physics are compatible with this, every single one of them. But that's not evidence of them. You can always make a theory compatible with anything else. But for it to be evidence, for your theory to be reasonable to believe, you have to go beyond just.
It has to go over and above the previous evidence, and I do have an experiment that does that. But I'm just talking right now at the philosophical level why we are prioritizing materialism over idealism if materialism is never in any of these scientific theories itself, and if
it is.
What I'm saying is you're saying, johanan idealism doesn't explain anything that the previous data doesn't explain, right? And that's all well and good. But the problem is I'm flipping it around and saying, well, if that's the case, then why are we not saying, materialism you could just throw in the word materialism instead of idealism, and the exact same statement is true. And so there's no reason prima facie to equate scientific evidence with material evidence.
Because all of the things are assumed in the hypothesis to be material.
See what I'm saying?
We're talking about material things. So we assume that the matter exists and it is a physical material thing.
But that's an assumption. There's nothing.
Right. That's all.
There's no reason to make these. The theories work just fine without those assumptions.
That's true. But again, these are the assumptions that we started with. So again, the first theory, whatever assumptions it makes, that can be used to make testament predictions, is the one we accept. So because it started with the assumptions of.
Right, but those particular assumptions, though, are not needed to make the predictions.
It doesn't matter.
In fact, they're not scientific assumptions at all. They're philosophical.
It doesn't matter because they were used and they can make.
That's not really how science. That's not how science works.
Yeah, it is actually.
That's not how science works.
So again,
science doesn't.
Whichever.
No, because what you're doing is you're lumping in. You're creating a science with a philosophy, and therefore saying that because the scientific predictions came out, that therefore the philosophy is correct, and that's not quite. They're equivocating science with philosophy implicitly at the beginning, and then coming to the conclusion, here's the evidence, so therefore the philosophy is also correct. And no, it doesn't work that way because it does. It's not.
It does. That's exactly how it works. That's exactly why Newtonian mechanics.
You can't start with an assumption that it's all material when that assumption, you could dispense with it and make the exact same predictions. You've heard of the
No, no,
principle
no.
of parsimony?
No, that's exactly what underdetermination does. Like the reason we accept Newtonian mechanics, even though you can get rid of the assumptions and assume general relativity, is because it was first. The reason we assume the Copenhagen interpretation is true and that randomness is a fundamental part of the universe is because it was first and it worked. Even though string theory and the de Broglie pilot wave
When you
theory.
get to the Copenhagen interpretation, it's funny you bring Copenhagen up. It's funny you bring Copenhagen up because there's something connecting very directly to that
Right, I know, I'm
that links
familiar,
into
but
the experiment.
I'm familiar. But the point is that we accept his assumption that randomness is a fundamental part of the reality because that assumption can make testable predictions, even though you can get the same result by assuming it's wrong and assuming there's some hidden variable or the pilot wave theory or the many worlds hypothesis. You can get the exact same predictions, but we don't assume those are correct. We assume the Copenhagen interpretation's assumptions are correct because it was first. That's how science works. The ones that's first can be used to make
Right.
predictions as
What I'm getting at is, okay, what I'm making is, okay, there's something called the principle of parsimony, okay? And it
Occam's
basically
razor. I'm familiar.
means Occam's razor. You don't have the theory that has the most assumptions in it, or even more. You take the simplest theory that explains the evidence. So if there is a theory that says the moon goes around the Earth by way of both gravity and magic fairies, and there's another one that says the moon goes around the Earth by way of gravity, and they both have the same prediction, you dispense the one that says by magic fairy. Adds the magic fairies in there. They're basically Russell's teapot. There's no reason to add them, and you get rid of that, right?
No, Occam's razor only applies when you don't have one theory that makes testable predictions. So if you have a theory that makes testable predictions, it doesn't matter how complicated it is, it wins. Even if you have a simpler theory that can explain
No, no, no. But
things.
that's the thing, though, is that it's not just that theory here. Because what we're saying is that the theory that is making the predictions can be made simpler and make the same predictions without anything differing at
Right,
all.
but until you can
Basically,
make an
if you
additional
have
one,
a theory that comes in and says we can explain the orbit of Mars by the sun as well as by Russell's teapot going around it, and it makes the really nice predictions, but there's absolutely no reason to believe in Russell's teapot. And if you take that out of the theory, you discover that it affects Mars's orbit 0. There's no reason to add it in the first place, because now you no longer have one theory, you have two theories.
right,
One
again,
theory
this
that
was this
says
was already
there's
addressed
the
in the
theory and the
example.
modified theory of Russell's teapot.
This was already addressed in the example I gave with quantum mechanics and Copenhagen interpretation. There are simpler interpretations, but we don't accept them because they don't add anything new to the theory. The Copenhagen interpretation was first and it worked. So even if we come up with a simpler theory that can explain all this stuff, until it does something new, the Copenhagen interpretation is still going to win because it was first. So you have to, even if you have a simpler theory, until it does something new, the Copenhagen interpretation is still going to be the better theory.
That seems extremely ad hoc in terms of, I mean, it's basically doing science based on historical accident.
Yep, that's right.
Like,
That's how
like
science works.
if say someone came up with a simpler version of the theory, it makes science kind of arbitrary then, though, if that's the case.
That's exactly right. That's why I used the example of Newtonian mechanics. It's wrong, but it was first and it worked. So he accepted it purely by accident that Newton came up with that theory as opposed to general relativity.
But then they have the better theory comes along and explains it better. And explaining it
No,
better can either mean
no,
explaining this, explaining new data, or it can also mean explaining the same data more simply.
no. Explain.
And I'm going to be honest, and I've not seen, and this is the other thing, I've never seen in any of my theories. That's right. I guess you're going to pick something up for a second.
New default microphone. Okay. All right. Can you say something real quick? Make noise. Can you, Johanan? Can you make it? Hi. All right. Let's see. Um,
Okay, well, let's talk about a new test then.
okay.
Oh, I can hear you typing.
Oh yeah.
Okay, so
The chat is. I'm making sure everything's
I'm
working outside. So.
okay. So in quantum mechanics, as you know, when you're not measuring or observing a particle, it does not take on definitive properties, right? And of course, we'll get into the difference between measure and observe in a moment, but you understand that far this far, right?
Right. The collapse requires observation.
Okay, so now you might say, well, it's just a detector that's doing it. It's not an actual mind doing that because you have a camera there and the camera collapses the wave function just perfectly, right?
Yep.
Well, the problem with this is that the camera is made up of little atoms, which are in turn made up of little quantum particles, which in turn do not exist before someone collapses or measures of little atoms. So you have another camera looking at the first camera to collapse it so it can collapse the electron coming at the target, right?
Yeah. Is this
So
Wigner's friend?
what?
Wigner's friend, essentially.
Exactly. Well, it turns out now beforehand, Wigner's friend, they didn't like Wigner's friend, okay? And there was a poll done in, I believe it was 2011 on this. And they showed that some 52%, I believe it was, of physicists, was it 51%? No, it was 57%, I believe, said that they agreed that the mind is in the math of the physics, okay? And now the funny thing with this is that only 51% said that it matched, 61%, and forgetting the exact number. I do remember it was 6% that thought it was within, it was also applying to reality, and 55% in turn said it was in the math but didn't apply to reality, which is very peculiar because...
Do you remember what the study's called?
I believe it was a screenshot of attitudes in quantum mechanics. You can find it on Sean Carroll's blog under the most embarrassing graph in physics.
All right.
Now, what's funny is this is just to show you how plastic these views can be. 6 years later, they did another study, and they asked the exact same question. And I'm going to try and find that study if I can here. It's been a little while, but I'm going to see if I can dig it up. They asked the same question, and the polling had shifted now, and a full 22% of physicists had said that consciousness, like the observer, affects the wave function and collapses it.
Right. I think that was due to the delayed quantum eraser, where they showed that was actually the case.
Yeah. So now, what's interesting that was like a huge spike in it went from a view that was hardly held by anyone to an entire fifth of the community did it, which you think that's, you should say that's not a majority, but when you realize what the attitudes in quantum mechanics are, other than Copenhagen as kind of a default position, no one interpretation has a majority. They're all pluralities, like many worlds, which is very mainstream. That literally is the mainstream materialist alternative to the immaterialist Copenhagen interpretation, or instrumentalist Copenhagen, depending on, they lump together instrumentalists and immaterialists together there for some reason. But MWI, meanwhile, only had 18% in the first poll, and that was still considered a mainstream view. So this was, what I'm saying is that by putting it into the 22%, it puts it into a mainstream quantum mechanics.
Right.
Simply because, there are multiple mainstream views of quantum mechanics.
Right.
So now what's interesting is that was in 2017. However, now Wigner's friend, as you know, it says that the mind collapses the wave function, okay? And that would include, it's not just a microscopic measuring device that's outside of our mind's range, because they've also showed in 2011 that macro realism is false. So, your computer, even though it's not going to quantum tunnel through your table or something like that, because the probability amplitudes are so tiny at that level that it's not gonna you're not gonna see any goofy, spooky quantum effects at your level. It still is not. It's still going to have the quantum property of not rendering until you look at it. It's still going to be in that fuzzy quantum mechanical blur until you look at it. And so, even if the blur is very tiny, so this, if Wigner's friend is the case, it will include necessarily our conscious perceptions. So your sensation, your mental sensation of looking at the screen, that is a thing that comes out of collapse. Now, as of February of this year, they conducted the Wigner's friend experiment, and they showed that specifically that a particle, depending on which frame you're in, is either entangled or not entangled at the same time. And of course, entanglement is where two or more particles share the same wave function. So what it's saying is that in one frame, the two particles that share the same wave function are in superposition, and in another closer frame, they are no longer in superposition, they're collapsed. And so collapse is relative to frame, right?
Right.
So
Schrodinger's equations.
With that experiment, they show that if collapse is relative to frame, that is the Wigner's friend experiment.
Right.
That's the von Neumann. You're seeing two steps of the von Neumann chain. One is entangled, one is not. That includes our frame as well. And if it's our frame though is all mental perception.
I'm not seeing how this relates to your argument. How does this relate to your argument?
Well, the point is that when you're looking at, I'm sure you see the blue outline of the screen here, right?
Yes.
Okay, that blue is a qualia. Qualia is an immaterial mental item, correct?
Right. Well, it's mental.
Okay,
yeah.
but that is also.
Go ahead.
It's what I'm saying is it's defined purely. Okay, let's if we define terms. Mental is, in philosophical sense, purely first person terms. Okay.
Yeah.
Okay, so what I'm saying is the first person data that you see on your screen is also in the wave function, and it collapses out of the wave function when you look at it.
I don't see any evidence to support that yet. We don't have any connection.
That's the Wigner's friend. What I'm saying is
no. The experiment you showed just showed that the collapse can occur. It doesn't show that qualia causes the collapse, because the collapse can still be caused.
What it specifically showed is that collapse is relative to frame. Okay.
Right, but frame isn't only conscious.
So
frame is there's lots of different frames.
There's lots of different frames, but the point is you also have a frame, correct?
Right. Yeah, we are definitely
your
one
mind
of the
has a frame.
collapsors.
There are many frames. I have a frame, and your headphones, which are non-conscious and non-conscious item, have a frame. But the fact of the matter is you have a frame as well, correct?
Yes.
Okay, and in your frame, and we're going to get back to the physical. We can talk about particle detectors and cameras and so on and so forth that are not conscious in a second, but just for the time being, single that out for a minute and think about just your frame. Your frame is collapsed in the wave function in here, and when it does so, what it sees is blue qualia on the screen, correct?
Yep.
Which is purely first person defined. Okay, so that is purely mental, correct? Mental in the sense of being first person. It's
yes,
a first person.
First person.
Okay. That first person state in your frame is coming out of the wave function. Okay?
Yes, so is everything.
Okay, so now if that's the case, and if reality is uniform, so the laws of physics are the same in all the different frames, even if the outcome is different, the laws of physics that are defining those outcomes are the same, right?
Well, not necessarily, because we know that gravity actually changed. Like it was repulsive at the beginning of the universe, so they're not always the same. No, but they're in general the same.
Right, but that's because there's a deeper principle that is causing it to be that way under that one circumstance, one condition, and a different way under some other condition. So, the laws of physics being the same in all of nature, that's basically an underlying assumption in philosophy of science. We need to assume that to do science, and that's actually well recognized that we need to have that to do science, right?
Well, no, again, because we don't. We assume that most of them stay the same under certain circumstances, but we can show that some of them can change under other circumstances. So it's not an assumption. It's usually a general rule of thumb, but it's not a required assumption to do science. You don't have to make that assumption. You can actually specifically hypothesize that some have specifically changed. and then use
Okay, but
predictions to try and see how it changed.
right, but when it changes, like say you talked about repulsive, the audio blurred out when you said it was repulsive under what condition?
I
The
don't remember.
gravity?
It's the gravity, the
The
early
universe?
universe inflation, Guth's early universe inflation.
Right. Okay, so the point is people try to describe it different ways. They don't say that, well, the laws of physics just change. They say that there is some deeper principle, like they will appeal to, you know, the vacuum, for example, having properties that change because there was a quantum fluctuation that had a runaway, whenever there's a quantum fluctuation, it produces a tiny amount of negative energy as well as positive, and so it somehow produced a runaway effect where all the negative energy just kept building up and building up.
Well, right, that's the point. We can assume
So,
that some laws of the physics do change under certain circumstances, given other laws of the physics that are consistent. So we say some set of the laws of physics are consistent, and if given these
okay,
consistencies, we say
that. So what I'm saying is, at the root, the laws of physics that those laws of physics that are changing are really just those are more derivative laws of physics. Like the law of like Newtonian's law is a derivative of general relativity, right?
right. But we can always go further
And
back and say the
Newtonian
things that
gravity doesn't really apply.
we can think that the things that we
Newtonian gravity does not apply.
the ones we have right now that we think are the fundamental laws could also be derivative. We just don't know it yet. We don't have any hypotheses of that yet, but they could be. So those could also change or be hypothesized to change at some point. We don't assume that all the laws are fundamentally universal as a necessity. It's just a working assumption as a rule of thumb. It's not a necessity.
Your audio is I can't hear your audio.
Um, we
Oh,
don't
now I can hear it. Now I can hear it.
Okay, so we don't assume the laws of physics are the same as a necessity. They can change. It's just a rule of thumb that we use to make predictions. So we can specifically hypothesize they will change, and even the most fundamental ones could actually be derivative and change. We could come up with hypotheses for those later. We just don't know yet. We just don't. So it's not that we must necessarily assume they don't change. That is not the case.
Right, but when you start doing science, you don't do science by way of saying, you know, we're just going to match these empirical. I mean, we do match empirical predictions to theories and get results and so on, but we start with the assumption that there is some truth out there that nature has an order to it, right?
Right, that's a
And
working
that order
assumption.
is the same, and
Right.
so therefore, right, and it's a work. It's a good assumption. Okay, I mean, that remember when you said at the beginning how when you start doing your theory, you take the theory with its assumptions as is,
Right, they're
even
working
if it's the first.
assumptions.
If it's the first theory, you take it with. Yeah, well, the theories, all the theories thus far have adopted as part of their working assumption the assumption that the the laws of the fundamental law of physics, whatever nature basically has a single order it follows everywhere, and that everything, if there's some variation, that's because it's not because nature is just randomly changing on us. Is that there is some deeper structure or order to it that is causing that to occur, right?
Right, there is some fundamental absolute truth.
Okay, yes. So if that's the case, then if it's true that you are collapsing blue qualia out of the wave function in your frame, then that blue qualia, which has a first person, you don't want to use the word mental, you can use the word first person for the time being. It's also implicit in the other wave function collapses, even if there isn't, say, your photodetector is not a mind. It's still what it's collapsing out of the wave function is a structure that is comprised of first person states such as qualia and so on.
Right? So I wouldn't disagree with that.
Okay, well, that's kind of cool because if that's the case, then what you're just saying is that therefore the rest of the information in the universe is first person or mental,
No,
which is
no. So the first person experience, like a detector that causes the collapse of the wave function, is a composite of lots of matter. The mind could be the same thing. It could be a composite or emergent property of other things, like material things. And so it's not saying that our first person things are fundamental. That's not what it's granting. It definitely, our first person experience can collapse the wave function, but that doesn't prove that they are, in fact, some kind of inherent ontology. They could just be a composite, just like the detector is a composite.
okay. Well, they can't be a composite, and the reason we know that is they're not when you have a composite, right, it's emergent, right?
Uh,
So a good example of an emergent structure is an anthill, right?
what
You have ants
composite
that
and
will
emergent aren't the
decompose
same thing.
themselves.
Composite and emergent aren't the same thing. Like waves are emergent, bird flight patterns are emergent, but they're not necessarily a composite. So I wouldn't say
Okay, bird flight patterns are emergent from the behaviors of individual birds, correct?
right.
And likewise, water is emergent from individual particles, correct?
Yep.
Of water,
Yep.
waves, I mean,
Yep.
and the motions of those individual particles.
Right.
Okay, so the point is you can, in principle, take a computer simulator and you can say, okay, we're going to model the behavior of this one water particle, and we're going to add another water particle in, and it's the behavior of this other water particle, and you keep adding them on, and they can interact with each other, and you can predict everything from basic, just the basic physics of the underlying particles, right?
Except
And
quantum
there's no new
uncertainty, but
structure.
yes. Other than quantum uncertainty, yes.
Okay, except quantum uncertainty, but
Yes, in
okay.
general.
So the
So
point is you can't get you can't derive or rather you can derive the behavior of all the properties of the emergent level from the underlying substrate level,
yeah, as long as you know all the laws.
right? The follow?
Yeah, as long as you know all the laws.
Okay. And assuming you know all the laws, and assuming you got it all programmed into the computer, you can get all the individual water particles, and you can therefore calculate the behavior of the wave from all the individual water particles.
Yep.
Now, that being the case, if it's emergent, you can then, in theory, do the reverse. You can say, well, we got this water, which is what we did. In the end, we have these water waves. We studied, hydrodynamics first, and then we eventually got people doing chemistry, and they realized, well, oh, the water particles, there's actually little molecules made up here, and they're made of hydrogen and oxygen atoms, and we broke it down, and we took the emergent structure and we reduced it,
Right, reverse
and we
engineering.
were able
Right.
to break it apart until we get back. Okay, so now therefore it follows that if something is emergent, it is also therefore reducible, right? You can
Yep.
reduce it back down to its substrate base.
Uh,
Okay,
yes.
so now
I mean, there are
if
some
mind
emergent,
is emergent,
like there are conceptual emergent things, like the angles of a triangle adding up to 180 degrees. That's an emergent property, but it doesn't reduce to anything. So there are emergent properties that are irreducible, but I would say that consciousness is reducible. So yes.
well, so the problem here is when you say consciousness is reducible. Now, a good example of consciousness being reducible is the green copy link icon up in the screen here, right?
Yep.
Now, green, as you know, is a combination of yellow and blue, right? You just reduce it down to yellow and blue.
Yep.
The problem, though, of course, is that yellow and blue are themselves mental first-person items. Now, when I ask you to reduce a primary color, such as red or blue, though, well, let's try and chop up the red or the blue, right? So I chop the red or blue up. I can zoom into the screen, and let's see if we can reduce it to something more fundamental than blue or red. And the problem is when I do that, and I kind of zoom in on if I had like a scroll feature on like I do in Photoshop or something, a scroll feature, and I could just zoom in on the screen, all I'd see is more red and blue. I wouldn't
Right.
see anything.
So let me preempt your argument here. So if we take a CD and we put it into a CD player and it plays a music through a speaker, the sound in the speaker, no matter how much we look at it, we will never be able to reverse engineer the CD. The reason is because the language is arbitrary. It's the Gavagai interdeterminacy of translation from Quine. The fact that the sounds we're looking at that are produced by the CD, we can't look at those and try and reduce the CD, the order of the CD, because there's no connection between the two. But it doesn't mean they're not emergent. The sound is still emergent from the speakers caused by the CD. It's just the fact that there is no connection between the sound that determines the order of the way the CD is, because we can change the CD in many different ways to produce the same kind of a sound. There's no necessary connection. The same thing applies to consciousness. The fact that we can't reverse engineer how it works in the mind doesn't mean it's not reversible. It just means there's no necessary connection between those two that we can find yet.
Okay, if that's the case, and if that's the case that there is no necessary connection between them, then you have this kind of peculiar situation where the mind emerges, but it doesn't. Basically, there's a step missing in between. it's something you can't predict from the underlying substrate. It just appears at this level, and you can't predict it, right? Is that what you're just
Yes,
describing in this case,
we can't
essentially?
predict it
So
yet.
it's a
There could
different
be.
kind, okay, you can't predict it yet, but the point is you first-person items are intrinsically irreducible, and this is
No,
a
that's
point that
false.
Joseph Levine pointed out.
That's false. That's the example I use, where if we listen to sound from speakers, you can't say they're intrinsically irreducible, because they are reducible. We just, until we actually look at the
Okay,
computer code, we can't
but
reduce
a
them.
third-person item has no a third-person item. A third-person item has no. There's nothing. It has no common properties with the first-person item.
That's correct, and there's no common properties between a sound wave and an order of ones and zeros on a CD. The same thing applies in both analogies. The fact that they are, it's a composition
Well, no, the
division
common
fallacy.
property is that the sound wave is not actually emerging from the ones and zeros in the CD. It's being translated. It's the ones and zeros in the CD are telling a little computer chip in the CD player to produce magnetic oscillations in a wire, which then produce a current and then oscillate the speakers in a certain way. So it's not. It's kind of a false analogy because it's not actually emerging from the ones and zeros. It's producing a causal mechanical effect, which then causes the speakers to vibrate in a certain fashion so as to produce the sound.
Which is exactly what naturalists think the mind does. The brain produces the mind in the exact same way. It's just a process that, just like the sound
But then,
process.
but that's the case, though. It's not. It's not really producing it. It's not really producing it. Then it's simply generating it. You're not generating it. It's causing it like in a way that like if I roll a cue ball, push a cue, shoot a cue ball on the pool table, it's going to cause the other pool balls to fall in the slots. But that does not equate the cue ball being identical with the 8 ball that it is causing to fall into a hole by.
Right. So I'd say the brain itself isn't consciousness. The brain produces or creates a process when the process is consciousness. So like the brain, if it's
The
dead,
cue ball, the brain is equivalent.
it's like the brain itself. If you can have a
The,
brain with
the,
no
the, the
consciousness, you can just turn it off. You can shut down all the electrical activity. You have no consciousness in the brain. So the consciousness isn't the brain. The consciousness is the electrical biochemical reactions going on in the brain. The interaction is the fundamental changes that are going on, like the water example of the wave. The wave is a part of the water molecules, but it's not the same as the water molecules. There's an additional property that's added there having to do with the motion and the interaction, and that's the consciousness. It is the emergent
okay, it
property.
seems to be identifying the mind as being something that is not a thing in itself, but a structure between things or a process, etc., of something else.
Right,
Like
an emergent
it's not an
property.
actual.
It's an emergent
Yeah,
property.
that the thing with that is that okay, so a property, and this gets into very basic philosophy of mind, but it's kind of interesting. A property, when something is a property, is always a property of something, right? Likewise, a process is a process of something. It's an activity of something that is doing something else, right?
Right, it's an emergent property of the brain.
Okay, so now the thing with that is if you have something that is a process or a property, you can conceive of an object as existing of itself in its own right, correct?
Yes.
With nothing else, okay. But you cannot conceive likewise of a process or a property existing of itself in its own right because it always has to be a process of something else. Like if I'm riding my bike, there is no riding that is just there that is existing apart from me and my bike, right?
Right. So like the process of a wave, there has to be water molecules for the wave to go through for it to exist.
Okay. So now if that's the case, you can't coherently conceive of riding happening without the bike. But you can coherently see with the bike just sitting there, right?
Yep.
Okay, now the problem with this is when you apply this to the mind, you find that, remember Descartes'
Yep.
foundational thought experiment philosophy? He doubted everything that he could possibly doubt and say what else he could conceive of that he couldn't doubt of, right?
Yep.
And the one thing that he could not doubt in the entire world of is his own mind. So, you can doubt. It's possible that maybe you're just in a grand computer simulation, like a VR game or something, and you've forgotten you're in there, or maybe you're dreaming right now, or maybe this is a solipsistic delusion and you have dreamed up the idea of brains. Not that that's likely, but it's conceivable at least, right?
Yep.
But the point is even if all that's true and the brain is conceivably just a dream, the mind cannot conceivably just be just a dream, because even if you are in a dream, the mind is still there dreaming.
No, that's false because I can imagine a universe with a wave. Like, so assume like we lived 2,000 years ago before we knew waves were water molecules. I can assume there is a universe with a wave in it, and I think this wave is an entity in and of itself. I just don't know that it's actually a composite emergent property. So I imagine a universe with a wave, which means I'm
I see.
imagining.
The masked man fallacy, essentially.
No,
So you're getting at is the masked man fallacy?
no, I don't think so. So here is the case: is that when you imagine a universe with a brain, that you just don't know what a brain is. You're imagining the sense experience that you have, but it doesn't tell you what that sense experience is made of. It could
So
be the
that's
case,
the masked man fallacy. That's the answer to the fallacy.
maybe, but I don't. I'd have to not familiar enough. I'd have to Google it to check, be sure. But so you
Okay,
assume,
here's the classic case. What you're describing sounds very similar to the mask. Let me just explain it for you and the audience so
all
we
right?
can be all on the same page here. Um, Really good. The kind of two standard cases of the masked man fallacy. There's the star Hesperus and the star Phosphorus, right? And one is the evening star and one is the morning star, and they are defined as separate, right? One is
Yep,
evening, one is morning. They're
yep,
different things. But then in reality, you realize that they're both the planet Venus.
yep,
Likewise, Lois Lane sees Superman flying around, right? Lois Lane also sees Clark Kent come into the Daily Planet, right?
yep,
And she talks to Superman and she talks to Clark Kent. They are two different people, right?
yep,
So therefore, they're not the same person. Okay, but the reason is she doesn't realize, of course, that Superman is Clark Kent, nor does she realize that Hesperus is Phosphorus. Okay.
yep, yep.
Now, the problem with this sort of thinking is that masked man fallacies always apply to something other than oneself. It's a
Right,
third
right.
person item,
So
something that you
let me
don't know the.
let me jump in there. So this is not the masked man fallacy. I'm not making the masked man fallacy. The masked man
All right.
fallacy, if
All
there's a
right. All
difference
right.
between A and B, then it's not the masked man fallacy because there's actually a difference. So in my case, I'm saying that it's you're making a you're
Okay.
making what? Can you hear me now? Can you
Go
hear me?
ahead. Sorry.
Okay, so
Yeah. Yeah.
what I'm saying is that you're making the assumption that what you're imagining in the mind, or a wave in this case, in the universe, is itself a thing and is not itself a composite. It could be a composite. You don't know. It could be its own thing. I don't deny that possibility, but it could be a composite, or it could be essentially just a material thing. So you've made the assumption that this thing you're imagining, a universe with a mind in it, that mind is itself a fundamental thing. It isn't a composite when it could in fact be a composite. So you're confusing epistemology and ontology. You're imagining our epistemic means of knowing consciousness, which is our conscious experience, and you're confusing that with ontology, that is in fact a substance unto itself, which it may not be. It's like I can imagine a universe with a house. Houses don't have the same properties as bricks, but if I put enough bricks together, I can build a house. So you gain an additional property just by adding more of the same thing to it. So you can get this new property of consciousness even from unconscious things by just adding more and having some kind of a relationship between them, a relation. So even though you can imagine a universe with a mind, that does not mean mind is essential. It just means that minds may be a composite of other things that you just don't know about yet. Just like we can imagine a universe with a wave before we knew waves were a product of water molecules.
Okay. So the thing with this is you I'm not just like imagining the mind to be its own thing. I'm saying, the mind may not be its own thing as it may, be identical with something that else. But the thing is that whatever it is, you can, the whole world could be a dream. The brain could not be real. It could just be like a dream that the mind is dependent on the brain, right?
Yep.
But the point is that the very fact that that is conceivable, okay, and is logically coherent, means the mind is such that it could exist in that kind of a world.
Sure.
Okay. And the thing is if it is such that it could exist in that kind of a world, it can't also be then the kind of thing that is necessarily dependent on smaller building blocks to make it.
No, that's
that are independent.
So again, there's multiple
Because
ways.
you can conceive of the world, you can conceive of consciousness without conceive of those smaller building blocks.
No, it's like saying I can conceive of a universe with leprechauns, but this universe may not have leprechauns. So even though we can conceive of a consciousness that is a fundamental thing and is a essence unto itself, it could be the case that consciousness is also a composite. So even though consciousness may be possibly its own thing, that doesn't mean it necessarily is. So you've seemed to have made the
Okay,
leap.
so what I'm getting at is it's not just what I'm getting at is that the fact that it is conceivable in this way is itself a property of consciousness.
Conceivability isn't a property. You can't.
Not the idea that it. You see what I'm saying? It's not. I'm saying that it. This means this is just because you conceive it means it has this part. You know, mine should be this goofy thing that have magic pixie dust in it or something. Like, you can conceive of that, but you could also conceive of a world that's not the case, right?
Right.
But I'm saying that in this case, we have the situation where the mind is such that you can conceive of it completely independently of all these other things. And even though in our world it may not be independent of other things in that exact way, the fact that you can conceive of it this way is a distinct property that is different than, if it was actually based on just fundamental material stuff.
Well, no, I'm getting that's an argument from ignorance. So it's like if I can conceive, like imagine we lived 2,000 years ago, and we know what waves are. They're big movements of water. Now I can imagine a universe with a wave. Now I don't know what it's made of. So at this time, it is logically possible for me to imagine a universe with just a wave in it. But really, I'm actually imagining that a whole bunch of hydrogen and oxygen molecules put together and acting on one another to cause a force. I just don't know it. So it's to me, it appears that that this wave actually has its own individual property of being able to be imagined without any other fundamental essence to it or composite. But that's only because of my ignorance of what a wave is. So even though I'm imagining a universe with a wave, and it seems to me that this wave has this property that it can be imagined independently, that's just false because it's actually a composite. I just don't know it yet.
Okay, I see what you're saying. I see what you're saying. That is literally a version of the mass man fallacy. It's very much akin to the Clark Kent and Superman analogy, or the Hesperus and Phosphorus analogy.
No, because in those cases they are fundamentally the same. But in this case, this is a confusion
They're
between.
fundamentally the same. Okay, well, I know. In that case, they're fundamentally the same. But what I'm saying is you're taking two items. Okay, forget the fact that there are one's dealing with composites, that one other one's dealing with things that are fundamentally the same. The point is that you're dealing with two different things that you don't know are actually the same thing.
Well,
In your case, there's a wave, there's a water wave, and then there's also a collection of H2O molecules acting mechanically on each other, right?
the argument I'm using is called the map and the territory, confusing the map for the territory. You're saying that the properties of the map are in fact properties of the territory, and that's the fallacy I'm describing.
Right, but what I'm getting is that in the case of mind, this has to be the case because you can't. There isn't if there is something additional to mind other than what we are aware of, then it is by definition not mind. Or more specifically, consciousness is a better way to think of it. You can't have a bit of consciousness that you are unconscious of because it's a contradiction in terms. So in the case of the water wave, you're unconscious of the fact that the water wave is comprised of mechanical H2O molecules.
Right.
But in the case of consciousness, you can't be unconscious of anything more fundamental than it because the more fundamental stuff, well, if it's there, you're not conscious of it, which makes it by definition not consciousness, but unconsciousness. So the notion that you can be ignorant of a layer of consciousness below what you're aware of is a contradiction in terms, because if you were, it would no longer be consciousness.
Right. I'm saying that consciousness is a product of other things which aren't conscious. So just like a wave is a product of other things that are not waves. Like there's no hydrogen oxygen molecule is a wave, but it can produce waves.
And it can be a product in that sense. I mean, we have, there are items in the world that are products of other things. The moving 8-ball is a product in some sense of the moving cue ball, but the 8-ball is fundamentally a different thing than the cue ball.
Right. So the product of the wave is fundamentally different than the hydrogen and oxygen molecules. They are not the same thing. But a new property is added when you have them in motion. That's why this is not the masked man fallacy, because they do have a new property. They have a different property. When the wave is in motion from the hydrogen and oxygen molecules, it has a new property. It is the property of a wave. And the hydrogen and oxygen molecules do not have that property. So these are two separate things. There is a wave. It does exist. It is a thing. But it's a new thing outside of the hydrogen and oxygen molecules. The mind can be the same thing, where it is a product of something else.
But in a way, well, that's not really the case though, because it's literally made up of the H2O molecules.
Right, but it has a new property that no H2O molecule has.
Well, in a manner of speaking, but in another manner of speaking, not really, because remember, you can predict that new property from the computer simulation of all the H2O
Right, right,
molecules.
but that's
The
only if,
motion of each individual H2O molecule contributes to the motion of the wave. It's
right.
part of the motion of the wave.
And I'm saying the same thing applies to consciousness. We just
Now, it may
don't
have a
know it
big
yet.
structure, but that same structure can be.
So I'm saying that we will also be able to predict the outcome of consciousness once we discover the laws that we don't know yet that are interacting with consciousness. So I'm saying that the same thing applies to the mind. It
Okay,
will
well, the
be.
problem is those, if you're treating those laws as, that's, okay, I see your audio's,
I'm not
I
saying
can,
anything.
I can't hear you.
I haven't said
Can you hear
anything. Go
me?
for it. Yeah, yeah. I haven't said anything. Go.
Okay, okay. Maybe it was just okay. There's a delay between audio and video, I think.
Mhm.
Yeah, I just heard you like a couple seconds ago, and I saw your mouth moving a couple seconds later. So there's a delay here. Where were we with the water molecule? The new structure appearing from the Sorry, I lost my train of thought. Um, okay, so repeat what you were saying a moment ago. We got mixed up with this stupid technical problem, and I lost track.
All right. So from my perspective, if we look at a wave, we can imagine a universe with a wave. But if we don't know what a wave is, we're going to see it as an independent thing before we know that it's just a bunch of hydrogen and oxygen molecules that are in motion. And so the wave itself is the
Oh
hydrogen
yes,
oxygen.
okay, I know where we were. I know where we were. No, I lost your audio.
I stopped talking. Go.
Okay, and now I'm going to lose my train of thought again, and I'm going to have to repeat the entire thing, and we're going to be doing this all night long, repeating this one stupid line over and over again. Okay. Anyway, though, I do remember where we're at, and what I was going to get at is the problem with this line of reasoning is when you make predictions from, you have your emergent your original laws, and you say that they cause some emergent trait to arise. That emergent trait is also described in third person terms. So, I describe bricks and mortar and wood and electric wiring and insulation individually and blueprints. And then I put all those together according to a blueprints, and I have a house. But now the problem is well, the house is described in third person terms as well, namely the third person terms of the blueprints. And you can keep going up. You can do city planning like this, and you can keep building more stuff. It's all third person terms all the way up. You start with third person and you end with third person. And it never, you can never get to the end conclusion of, first person. So let's say in the case of consciousness, I have a chemical formula of sugar, right? And it's written on a piece of paper, and I look at the piece of paper. It's never going to taste sweet. I can lick it all day. It's never going to taste sweet. And that's, you have this emergent structure here, a third person description of an emergent. And then you can say, well, maybe there's something more fundamental, right? And you write those laws down on a piece of paper and so on. And those will never produce the sweetness sensation in your mouth either. It's all third person stuff all the way down. It never actually produces the first person stuff because the terms are of unlike qualities. It's not a matter of, you can layer as much syntax as you want, but the semantics inside of it is going to remain the same.
That's
You're
the
never going to actually get to the first person.
that's the hard problem with
But
consciousness. I can describe your experience and
I
say,
know, right? But the fact that there is a hard problem is that's the problem. Is that's the why it's called the hard problem, right?
yeah, but that's
Because from a materialistic perspective, it's insoluble. And
no,
notice on idealism, there is no hard problem.
no, it still exists on every problem. So it doesn't help you even on idealism. Idealism just takes up the position of dogmatism instead of circular reasoning or infinite regress. But Agrippa's trilemma, the hard problem applies in all ideologies. It just has different posited solutions. So I can describe your experience in the third person. I can say
Okay,
you have the taste of
okay,
sugar. Now that can be true even though it can't be verified. So I can get my third person description of your first person experience to be correct. It can correspond to reality. So even though you're right that I will have to
Okay.
describe consciousness in the third person. It can still
The
be
thing is,
true.
okay, here's the trick. This is okay. This is why it's not. I'm going to get to in a second why it's not really a problem in idealism. But I'm also going to note something here about your apparently third person um, description of it, and we're going to discover something kind of interesting about the nature of third person entities. Okay. Notice that when you have a third person description, and when you're describing it, even though you think you're describing in third person terms, what you're actually describing is everything that you're experiencing of that description is first person. There's nothing about it that is actually third person in reality. It's you're describing it, but then what are you describing? Maybe you're writing on a piece of paper. Okay, well, what is that description on that piece of paper? You have on the one side, you have there's a white piece of paper that's white qualia. There's black ink or blue ink, and that's qualia, and it's arranged in a certain way, but it's arrangements between qualia, and then likewise that corresponds to a mental construction of what that description means in your mind, which is also first person. So everything about the description is first person, but then of course you're going to say, but johanan, that it still exists apart from my mind, right?
Oh no, I would say
It's
again
something
that's the confusing the map from the territory fallacy. So I can say if I draw a map with ink and it requires me to use ink to draw the map, well then the territory must be made of ink because I can't draw a map without ink. So therefore the territory must be made of ink because I can't. It's not possible to do it.
right. Okay, I get that. But then we're going to explore the territory in a moment because we're going to discover something very. What I'm getting at is you have your map and your territory, and in this case, you can't conceive of the territory without the map.
Right. But my
But
argument is that's just an argument from ignorance. The reason we can't do that is just like why.
but we're going to then go into the actual territory itself and say, let's suppose that it exists apart from consciousness for a second, or apart from the map, as it were, right? And we're going to see exactly what this territory looks like in its own terms in the third person. Okay,
Okay.
get rid of the mind. And we're going to see what that looks like by itself. So now, when you talk about physical properties, right?
Yeah.
You're talking about things that are matter or okay. So there's more. Okay, there's lots of things that are called physical properties. There's more derived stuff. There's like charge and spin and color charge and so on. And I think you would agree that those are ultimately arrangements of matter and energy in space and time, right?
Yep.
Okay, they derive from that. Okay, so now let's look at space and time for a second. Okay, so now, as you know, space. If you take all the objects out of the universe, right, and you ask where is the center point of the universe,
There isn't one.
it's kind of a meaningless question, isn't it? Right?
Yep.
It's everywhere and nowhere at the same time. It doesn't make sense to talk about. You can measure off infinity from both sides of the universe to get one, but then the problem is half of infinity is infinity still, and so the center point is infinitely far away from itself. But then the definition of space collapses because there's no way to define. Space defines the difference between locations, and that can't define the difference between locations.
Okay.
And likewise, you could do the same thing with time. You can freeze all of the events, and
I'm not seeing how
if
this
there are
relates to
no
your
events in
arguments.
history,
How does this relate to your argument?
well, this is setting something up. This is setting something up. Okay, it takes a little bit to set up, but when you see it, you'll see why I'm setting this up. Um, so space and time are purely relational things, right? They don't have an existence in their own right. They have to either relate events or relate objects, correct?
Yeah, they're emergent properties. They come from something else.
Okay. Now, matter and energy, meanwhile. So, what is energy? Energy is either potential or kinetic, right?
Right.
If it's potential, it means it's in a potential field which is extended in space, right?
Sure.
There's the moon is extended in the Earth's gravitational field in space. Okay, but then the problem is well, if it's that's how you're defining it as extension, sitting in an extension in space. Well, space is once again purely relational between items, right?
Yep.
And likewise, kinetic energy is also it's motion through space, right?
Yep.
And so that's also relational, right?
Yep.
And so this kind of weird thing is, well, energy then collapses. But you say, well, okay, well, you're a materialist, so maybe it all emerges from matter. Okay. Well, then let's go look at matter. Well, we ignore E equals mc squared for a moment because that obviously relates energy with matter. But
Can I preempt your argument? So
okay,
I know where you're going with this. Yes, all forms of known matter and known energy collapse at the Big Bang with space and time. We don't know what could be before that, but there can be other things other than matter and energy, like Nemo Arcani Hamad's amplituhedron, or other kinds of space time, like imaginary time, or Itzelbar's two-time physics, or all kinds of other things. So,
even though it's structural, it's a structure.
right, but his theory is that that can exist before space and time. So it is independent of matter and energy in
But
space and time.
okay, this is not where I was going. Not where I was going with that. This is not where I was going with that.
Okay.
Um, it was probably a good guess as to where I was going with that, but it is not actually where I'm going with this. What I'm saying is everything that you call physical, well, that reduces to space-time, matter, and energy, and space-time, matter, and energy in turn, they're purely, if you examine what they actually are, they're purely structural. There's no actual content of them. They have no independent content in their own right, is the problem.
Right, just like a
They're
wave
structural.
doesn't. A wave is structural. A wave is dependent on the structure of the water molecules that make it. All emergent properties have
Right.
that
The
feature.
point I'm getting at is that it's structural all the way down in this case. If you assume only third person, then it's structural all the way down. The the water molecules are made of hydrogen and oxygen, which are in turn made of protons and electrons and neutrons, which, if you think about it, those are in turn fundamentally, at some point, you have these fundamental material bits that are arranged, H2O wise, right?
Oh, right, right. So we don't know what the fundamental aspects of reality are. All we know about is the emergent phenomenon, which are matter and energy and space and time. But those could reduce to something
Right.
fundamental. We
But
just
as
don't
long as
know.
you that fundamental stuff, though, if you're going to assume that it's third person material stuff, what I'm saying is that whatever, no matter how far down you go, it's all, as long as you assume it's third person, it will always simply be structure, structural relations with no actual stuff to it.
Well, there's one of the physics theories is that relations are the fundamental nature of reality themselves, and they are purely physical. But that isn't the case. There
What
could you could
what
there
what
could
is
be
what is related? What is doing the relating?
structural realism. I think is what it's called. I don't. I'm not a structural realist, so you'd have to ask someone who understands that position. But
Okay, what I'm getting at, is it has to relate something.
well,
When
no,
there's a
that's the point.
relation, those things have to relate.
Structural realism holds to the position that relations themselves are existent essence phenomenon kind of existing things. I'm not a structural realist, so you have to ask them for more detail about that.
Well, okay, if that's the case, okay. Well, actually, it's kind of funny because I hold to a form of this, not the exact version you're applying, but I do actually hold to a form of this. But the problem with this is you can go two ways with this, and one of the ways is if you take a structure by itself. Well, what is a structure by itself? It's a mathematical object. This is like Tegmark's,
No,
mathematical universe hypothesis, right?
they reject that. They don't say it's like just a mathematical object. Mathematical objects describe relations, but they are not what relations ontologically are. So they're saying relations are like an essence a thing, just like you believe consciousness is a thing in and of itself. So they're just saying that.
But okay. What I'm saying is that's like they can be the same thing as long as it's like the relation and the thing in itself are the same thing if it's a platonic relation, like if it's a platonic object, which is what Tegmark's position is that the universe is essentially made out of math. Math is the platonic object. The problem there, though, is that platonic objects are immaterial, and so he's basically saying the universe is made of immaterial math stuff.
Right, they're going a different way with that. They're not taking the classical Platonic route that Platonic objects are abstract. They're saying that there is a actual physical kind of a thing, which is relations, which does exist, and it is there just as much as matter is there, or more so than matter is there. They're saying it exists like you believe
Right, but
consciousness
relations
exists.
by themselves, like, it's like having riding without a bike. It
Well,
doesn't
right, right.
make
I
sense
agree
to
with
talk
you.
of riding.
I don't like
Right.
structural realism, but that's their position. So if you want to argue that, you'd have to take up with one of them because I'm not one. I agree. I don't
Okay.
like it, but that's their argument, and it is a
Right.
valid
That's
interpretation.
not a structural realist of that nature, though, because if that's the case, and if you don't go down the Tegmark route, which is kind of the spin off of it, which kind of makes it a concrete thing again via Plato, but putting that aside, if we go the other route and we say there is a structural, if you don't like the fact that there's these structures there, the structures have to be relations between things.
Right.
They can't exist in one right.
They correlate to some
And
kind of
what I'm
material something. They correlate to a physical existing thing, like a law of nature that we just haven't discovered yet.
okay, so well, the law of nature itself is structural. I mean, if you write it down, in physics, everything's done as math, and so if you do the math of it, you have you see a set of relations between symbols on a chalkboard or a book or something.
Math
It's
describes
all
it.
pure relation.
So math describes the thing in of itself, but is not the things.
We have to ask then though what it is that what are those little symbols in the equation describing? They refer to something in reality that's out there. What is that something that they're referring to?
No, they're just this is
And then we look at
language.
that something.
So math and logic are
What?
formal languages that describe reality. They don't they correspond to something that exists, but the math and logic themselves do not exist. So it's not like the the plus sign is a thing in the universe.
So let's talk about the fundamental things that they are describing though then, right?
Yeah, which is some
And
like
we
a
got
law of nature, some aspect of reality.
what is the fundamental essence of those things that is existing that they are describing?
I have no idea.
And the problem is when we try to define regardless of how many mathematical laws and how far down we go, those laws are always structures. There's nothing that equal as anything other than structure if we assume it's third person.
So far, that's only true so far. So
Now, when
so
we add something like
far,
idealism in, we can say,
so
well,
so
no, it's not just so far. It's a matter of okay, what it's a matter of is a matter of methodology, as it were. Okay, it's a here's an example. Let's suppose you make remember those paint by color paintings you see at the store when you're a kid,
mhm.
and you see like little outlines and there's numbers in them, and you take the paint palette and you start painting in the numbers.
Yep.
Okay, what you're basically saying is you could be making a paint by numbers system that has smaller and smaller sections of numbers in it. You can keep going down, and at some point, therefore, color is going to pop out. It doesn't work that way. It's the reason that there isn't any color there is not because you haven't, you know, made small enough sections with numbers in it yet. It's that the very process of making numbers at smaller and smaller scales like that, like little smaller sections of numbers, is that kind of an activity is never going to produce color because it's not something that produces color. It's the very nature of it is such that it simply makes smaller and smaller squares with numbers in them.
Again, that's a composition division fallacy. So again, I can say there is some property like waves that exists independent of the things that make it. So the things that make it, there's no property of wave in any of the H2O molecules. It doesn't exist. There's no property of waves in molecules. But if you add enough together, you can get a wave. So we can say that the structuralism that we see may be emergent from some more fundamental thing that isn't structuralism. Or we could do like what Nima Arkhani-Hammad does. And
Here's the thing: is that okay? You're saying this is a composition fallacy on my part. What I'm saying is this is actually an equivocation fallacy on your part because the reason is you're equivocating syntax with semantics. The syntax is the outlines on the piece of paper with a number in it, or the canvas with the numbers in them, and the semantics is the paint you put in. The syntax is a relation between things. The semantics is the things in themselves.
that's
There's the things in themselves
that's a
that are
reference
relating.
to John Searle's Chinese room argument.
Well,
No,
John uses it in his argument, but that's just a universal definition of what syntax and
oh,
semantics
right,
are. They're,
right.
they're
So, but no, so that is not what I'm arguing. I'm arguing that in the case of syntax and semantics, uh, just using the case of language because it has to do with language, our semantics are a result of the syntax. So if you see, for example, a bee sees a flower open up, the bee is going to interpret that as a signal to go get the nectar of the flower. And then if we wait a million years until the bee evolves to have some kind of cognitive capacity to apply meaning, it's going to see meaning and apply semantics to this syntactical interaction. It's going to say there is a syntax of I see flower open, therefore get food, and it's going to apply the semantic meaning to it afterward, post hoc ergo propter hoc. So the semantics follows the syntax. You can get semantics from syntax. It just takes an emotional drive to do so. So it's that doesn't apply in the case of the example I'm using. It's still the semantics in this context can still be emergent from the syntax.
How do you get these? I mean, how is it? Okay, so let's suppose that we are 100 years out from now, or 200, or even 1,000 years out from now, and we have a perfected neuroscience. Okay, and I'm not going to imagine what that is, but it has to be something that we can conceive of, right? Because our counterparts 100, 1,000 years in the future have figured it out, supposedly, right?
Well, hypothetically, supposing they don't solve some way to make our brains more powerful to be able to compute things that we can't do, which may be possible.
Okay, so maybe the singularity happens in 20 years, and then we can compute it out in 5 years later, and we don't need to wait 1,000 or 100 years.
Right,
Okay, so maybe
right.
25 years out we have the singularity, and then 5 years out, the Mr. Skynet computer brain figures out a way to help us figure it out in only 5 years. Okay.
Yep.
Now the problem is whatever that solution will look like. Okay. The problem is it's something that we have to conceive of. We have to be able to conceive of. And the problem is it's not in principle conceivable to conceive of getting semantics from syntax.
Yes, it is. We can do that already. That's the interdeterminacy of translation from Quine. So, like, his Gavagai example, where the guy
Well,
points at the rabbit and says it's Gavagai, and we don't know what Gavagai means because Gavagai could mean infinitely many different things. We have no idea what it means, but the guy who's listening to it imposes a meaning on it. He says Gavagai means rabbit, or Gavagai means hare, or Gavagai means mating season, or whatever. The meaning is imposed post hoc ergo proctor hoc. So the syntax exists. There's the guy pointing at the rabbit and calling it a Gavagai, and then the meaning, the semantics comes after that. It's imposed on to have some kind of pragmatic use. So we can imagine that. That is imaginable.
that's not a scientific theory anymore. That's a subjective interpretation of a scientific theory. You have your scientific theory, and then you're imposing your interpretation of it on the theory. Your interpretation of it, your imposed meaning on it is something that's external to the theory.
Well, right. This is philosophy. We can't do scientific tests on this yet.
But that's the point. Is that it's the reason it's philosophy and not science is because it involves the first person states you're imposing on it, the first person interpretations you're imposing on it.
Well, the reason
Science deals categorically with the third person. Okay.
well, no, no. So the reason
And
it's philosophy and not science is because it's not testable yet. There's lots of things that were philosophy that became science. Like, for example,
well,
using.
what I'm saying is, even if we have that perfected,
Like, I can give you an example.
even if we have that
I can give you an
perfected
example.
theory,
Let me like one point in time, we could make the exact same argument for Einstein's general relativity and space-time bending. Time understood as a philosophical concept could not have the property of bending 400 years ago. Like it's not literally not conceivable by anyone at that time. They could not imagine that occurring. But then we wait until Einstein. Einstein makes predictions, says time bends. Here's what happens. Like how he conceived of it, no idea. Like the idea that time can physically bend is a very strange.
actually, if I were Bishop Berkeley, I could conceive of space bending.
Well, okay, okay, maybe so. Maybe you could, but that's the point. Is that? But that is the point. Is that?
The reason is that the space being something that isn't bent, doesn't have any fundamental properties, is a materialist assumption. And when you go to it's funny because the reason space bends, whether you don't want to call it idealist if you don't want, but you do have to kind of admit, I think, that the kind of metaphors that you use sound very idealistic in nature, right? The quantum gravity talking about space and emerging from information. You could say, okay, I'm not making an argument for idealism here. I'm just saying that as a metaphor, it fits. You can see how this notion of it being relatable to a mind or a computer is very conceivable here because it's you have material existence emerging from an informational existence.
Right. The
And
analogies
so,
and our analogies are always compatible with minds because we use minds a lot in our analogies. Like if you say it's the type 1 and type 2 errors. If you see the bushes rustle and you think it's the wind and don't do anything, you get eaten by the lion.
I know. That's why I said I'm not making an argument for idealism with that. I'm just saying it shows how you can actually. You know what Leibniz did, and it was just kind of cool because he had a very careful philosophy. He came up with a form of idealism and based on monads, and he actually said, based on this, that he predicted space would be emergent, and if the space is emergent properties, then you can figure those emergent properties in various ways to produce things such as space curvature or space bending in the time and so on. So it is actually conceivable 300 years ago to do this because Newton's contemporary Leibniz actually put this very, very careful derivation of first everything's made of little mental monads, and then how do we get physical reality from these mental monads? And you have this whole Leibnizian construction. And from that, he said that you should, under his system, there should be such things as emergent space.
All right, so just to go back to my point was that just like space and time bending was not imaginable for some people, it may not be imaginable for us to be able to cross the syntax semantics barrier yet, but that doesn't mean it can't be done. It just means that we lack the cognitive capacity to process that, just like people did in the past.
Daniel Dennett can pull this off somehow. I guess what I'm getting at is, how do you get the ones and zeros, or the mathematical relations? How do you get that to produce things like qualia?
No idea, but it doesn't mean it can't be done.
Okay. So, but what I'm saying is, there's a, how am I saying this? There's like a conceptual gap, right?
Well, right, just
You
like
would
there's
agree
a
that
conceptual
syntax and
gap between
semantic
time bending. There's a conceptual
thing.
gap between those things, but it doesn't mean they can't happen. It just means we can't conceive of it because we lack the mental capacity to do so at this time. So the fact that there's a gap.
Gap at a much deeper level. See, time and space are things that are empirically defined. They're not really philosophical. They're both third person things that you can relate to each other. Even Newton relates them to each other. He just doesn't relate them in such a way that they can bend. He relates them in terms of motion and forces and so on, right?
Well, that's the thing, is that one of the biggest criticisms of Einstein's work was that the philosophers were saying that time was a philosophical concept, not a physical concept, and the philosophical concept can't bend because it is, just like how you're saying, describing syntax and semantics, for the exact same reason that there's a contradiction in the properties or the ontology of the two categories. They can't align. But again, they were just wrong.
All right. I think the issue here, yes, they were wrong in that case, but then we look at why they were wrong, and I can see why you're making this comparison, and it's a good jump, but I think it's also wrong. And the reason I think this is the case is what the philosophers were dealing with, and this is kind of funny because I get into William Lane Craig fans. I used to, until I got sick and tired of it. I got into arguments with them about this all the time because, of course, they're in favor of the A theory, and it's like, no, this requires all these more premises, and one of the premises, absolute space, is philosophically problematic. And
yeah, the consensus is neither A nor B.
No, it's not even more parsimonious. It's twice as unparsimonious. I'm banging my head into like, you don't get it, for crying out loud. Anyway, okay, so the issue here, though, is that they're dealing with an intuitive notion of time, okay? Your intuition says that time is A theoretic, even though that we know it's B theoretic, right?
Well, the consensus is neither A nor B right now in physics. So.
Okay. Well, actually, as far as I know, most physicists I'm aware of believe in B theory.
I actually have the poll right here.
Carroll and Kaku. It's actually kind of cool because all the popularizers I've seen have described it in B theoretic terms, which is interesting.
See if I can find the actual.
Is this philosophers or is this physicists? Because I saw the poll of philosophers on this, and they have a more complex situation. But is this physicists or philosophers?
Physicists.
Wow, that's kind of cool. I'm actually, because I have heard there are ways to play with this such that it's like
it's like a combination. Like there's
a growing block, like the growing block model. Okay. This is interesting. This is actually a topic for some other time when we want to shoot into this. But the thing that I'm getting at here is in the case of the A theory of time, yes, the intuitive concept of time does not bend, okay? And it cannot bend. But the thing is that's an intuition. Now, some philosophy is done based on intuition, okay?
Right.
And I think that is actually bad philosophy, largely. I mean, it didn't seem like bad philosophy at first until we discovered, science and cognitive science physics and so on, they produce all these intuition pumps and everything starts falling apart. And next thing you know, everything you thought was intuitive is collapsed. A good example of this is even if you take away my idealism for a second, the whole notion of emergent space-time in some ways entails that the world is an illusion. Right? Even if you don't draw idealism out of that as I do, right?
Right, right, absolutely.
Wisconsin and Minnesota is a construction. That does have to kind of make you stop and think. I mean, that does very much sound like the Matrix, is it not?
Right. Well, it's the exact same thing as when you say this object I'm holding is solid. Like, no, every object you have is 99% empty space. There's no solid object anywhere.
Yeah, and the empty space now is also a construction as well. It's a matrix construct and so on. Okay, so taking that all aside, the point here is they were basing their philosophy on intuitions. Okay, and now this is kind of funny because you're probably going to fumble this from the opposite direction. But the William Lane Craig fans, they fumble it from the first direction, which is always infuriating to me as well. They insist that a priori constructs are intuitions and they are infallible. Now, what I do is I say there are a priori principles that are also intuitive, such as the cogito. It's intuitive to know that your own mind exists, right?
Well, I wouldn't say that's an intuition. I'd say that's absolute truth. So it's not. It wouldn't be an intuition. But
It is an absolute truth. What I'm saying, it's both. It's both at the same time. It's an absolute truth in the a priori sense, and it's also intuitive.
okay.
And so the problem here is that the philosophers who were trying to refute Einstein were doing was they were confusing their intuition with absolute a priori truth.
Right.
And the two do overlap at times. There are a priori truths that are intuitive, but not every intuition is an a priori truth.
Right.
And the problem is when you then confuse those two, you end up with the situation where the a priori truth is not with the intuition is actually a priori true, and you can't get it. So what I'm getting at here, though, is that the syntax semantics relation is an a priori truth. It's definitional. It's for the same reason there is no such thing as riding without a bicycle.
Right. But my argument is that you're applying the definition of syntax and semantics to an existing thing, and you're assuming that that definition applies. Just like the philosophers took their intuitive definition of time and applied it to the physical thing of time. Their definition was wrong. Now, if we accept their definition, then definitionally time can't bend. Their definition was just wrong. So I'm saying that you're using your intuitive definition of
Okay,
syntax and semantics and applying them to reality, and your definition is
the
wrong.
problem here is that syntax and semantics are not something that exists apart from our. Okay, you've heard of the term rigid designator.
Right.
Kripke got into this a bit.
Kripke's, yeah, his name, the names, rigid designators. But again, so I'm saying that you're using the word syntax and semantics, which are constructs, we made them up, to describe something in reality. And I'm saying your description.
Here's an example. An unmarried bachelor, or I mean, a married bachelor, right,
Yes.
is a contradiction in
Yep.
terms, correct?
Yep.
Okay, well, the thing is you might have some fool who comes in and argues and says, well, no, because we might have not realized what a bachelor is yet, right? Because we maybe just like, no, that's not the point, is that bachelor is a rigid designator, right?
Bachelor is
Bachelor is a rigid designator for someone who is unmarried.
no, because bachelor is a construct of language, so it wouldn't be a rigid designator, because a rigid designator would be like something that refers to the same thing in all possible worlds, like the name of Saul Kripke. Bachelor doesn't refer to the same thing in all possible worlds. It's just it's an arbitrary
Yeah,
figure of language.
and the reason that it does that, though, the reason it does that is because we've defined it as such. It's a definitional thing we've made.
Right. So, but again, that's the point that I'm arguing against.
In reality, the concept of bachelor is not like a natural thing that exists out there. Because I mean, an unmarried guy is no different than a married guy. Nature doesn't care between. Nature just sees them as both Homo sapien specimens, right?
Right. So when we refer to syntax and semantics, we're talking about language. The syntax is the structure of the language. The semantics is the meaning of the language. But when we're talking about structuralism, as in the stuff that exists in reality and how it can go from a third person description of experience to a first person description of experience, those are not figments of language. Those are figments of the world. Those are properties of reality. They are not definitional. They are like time
Yeah,
bending.
that's true too. But how you got a point there. You got a point there. The structures are there are things in reality, but they're relating things. Now you could maybe try and argue that they're not, but if you go there, then you're going to have to go into the structural realist camp, which you said you don't like. Remember?
Right. So I think they are relating
So
things.
if there is some solution to the hard problem of consciousness that gets past this barrier, then you're going to need to be a structural realist in order to pull it off, basically, which you said you don't like.
No, that's not the case. That's only given the conceivable solutions that we have so far. There could always be more solutions that we haven't conceived of yet, like time bending. At one point, no one in the universe had ever conceived of time bending, but then we conceived of it, and before that point, it was inconceivable. So there could be things we don't know yet that we haven't conceived of
Okay, well,
yet.
the problem here is that uh, unlike general relativity and space and time bending and general relativity, um, when it comes to consciousness, it's not something that exists. Time and space are things that are out there in some sense, right?
Yes.
But consciousness is in here, right? So when we conceive of it, our conception of it, in a sense, is it.
No,
Conception
that's
is a.
that's that's the
It's
confusing the map for the territory. You're confusing our experience of the thing with the ontology of what makes the thing. Those are not the same thing.
right, but that's in the case of consciousness. In case of third person items, you can you can say the map and the territory aren't the same thing. But in the case of consciousness, consciousness is different because consciousness simply is the experience.
Well, no, that's just conscious experience. Conscious experience is conscious experience, but that doesn't mean that's the ontology of what consciousness fundamentally is. It just means that's how we experience it.
If you get rid of the experience, if you get rid of experience, there's no consciousness.
Right, but consciousness is like it's like the wave in the water analogy. You the wave is a product of the water. You can't get rid of if you get rid of the wave, well then yeah, there's no more wave. But the wave can still be a
Okay,
product of more fundamental things.
there's no reason to believe that the mind is a. I'm trying here to point out that you can't get the you can't the hard problem it has an insoluble. The reason it's hard is because there is a epistemic problem.
Right.
Have you heard of Joseph Levine's explanatory gap?
Well, I'm familiar with the epistemic problem of the hard problem because you're trying to explain consciousness with consciousness is inherently circular, and so you'd always it's like using a ruler to measure the same ruler. You never know how long it actually was because you just say it's the same length as the ruler we're using because it is the ruler we're using. So you need some kind of external reference point to get out of the circularity. The problem is that applies to everything. It's Agrippa's trilemma. Agrippa's trilemma states that any claim to knowledge rests on either circular reasoning, infinite regress, or dogmatism. In idealism, your solution to the hard problem is just dogmatism. You've just said this is the one fundamental thing which solves the problem. And that's a solution is just not accepted because there's no reason to believe it, just like there's no reason to believe the circularity or the infinite
Well,
regress solution.
when I say dogmatism, it's referring it's foundationalism, which it's not
Yes.
it's
I'm using
priori
those. I'm using
truths,
those
right?
synonymously. Yes. So foundationalism and dogmatism would be the same in this context.
Okay. So the case here is that like we know what consciousness is dogmatically, if you prefer, because we're aware of it. We're it's the Cartesian starting point, right?
Well, no. We know we have consciousness. We don't know what consciousness is. For example, if I see an optical illusion, I don't know what the optical illusion is. I just know I see an optical illusion. So it could be the case the optical illusion I'm seeing
Have
is
you
a
heard of okay? Remember Martians that experience pain with Kripke?
yeah. What about it?
Okay, so the problem with this is the Martian has a completely different neurophysiology than us, and you torture it, and it's still writhing in pain. It still feels pain. It's still a very unethical thing to do that, even though it doesn't have any C fibers, proverbial C fibers that are firing.
Yeah.
So you can't really. In the case of the Martian, what the Martian is describing here is experiencing is totally different than what the person is. Um, you know,
Imagining them to have experienced.
yeah, exactly. There's no connection between the pain of the Martian and the definition, the materialistic definition that the the human has applied to it. It's still the, they're saying, well, pain is C fibers firing. Well, in the case of emergent, no, it's not. It's something totally different. And so the point is that it doesn't attach to any one physical substrate. It's something that exists by itself, right?
No, that's the part where that's the exact same example I used with Quine and the interdeterminacy of translation. So if you point at the rabbit and say Gavagai, the meaning behind that is undetermined. It could mean infinitely many things, but you could actually stumble upon the same meaning just by guessing. So it's like, I'm going to guess that means rabbit. The person who says rabbit could actually mean rabbit. Those could mean the same thing. So the fact that there isn't a determined connection between the pain of the Martian and the pain of the person, they could still be the same thing. Fundamentally, we just don't understand it. It's like my example with the sound and the CD player. There is no determined connection between the two, but they could still be connected, related in some way. So the fact that there isn't a determined connection between the pain that the Martian feels and the pain that the human feels doesn't mean they're different things, or doesn't mean that pain is some kind of independent third party. It could still be just a result of two different processes working in the same way. Like I can use a CD to play music, or I can use an MP3 player to play music. They both produce the same music.
Okay, so maybe it's the same structure. It's the same structure that's there, right?
Something like that, yeah. So the same underlying.
So
mechanism.
this is the process. Is a process occurring?
Right.
Basically, so identity theory is full same process occurring. In one case it's in D fibers, and in one case it's in C fibers. Is that kind of what you're getting at?
Essentially, yeah.
Okay, so so the issue there is, well, a process is pure syntax. It's something that's doing things, right?
No. Again, a wave is a process, but it's semantics. So again, remember, the semantics can emerge from the syntax.
Well, no, a wave incorporates a process. But a wave
Well, the wave is the process. It doesn't.
The wave has actual stuff in it.
But remember,
it does exist. It exists as a composite of moving flow molecules. Now, it's waving. That's a process.
So remember my
the
argument.
Wave itself, though, is
we talked about this a little bit earlier, where the semantics can emerge from the syntax. So just like if I say the
right.
Gavagai example, the guy says Gavagai, that's purely syntax.
So supposedly.
Right.
Well, I guess the question is in order for that to work, in order for, say, our post-singularity minds to figure that out, some quantum computer super intelligence helps us figure that out. Whatever that theory is, it has to be something that we can conceive of on paper. You have to be able to say, well, okay, so we finally figured out the theory of consciousness that solves the hard problem, and so what we have is this big formula we've scribbled on the chalkboard, okay?
Yep.
The problem is, if we look at the formula, all we see are symbols relating more symbols.
Well, remember,
right?
This is where my argument about time bending came in. So you can make the same argument for time bending however many thousands of years ago before this was ever imagined. If you wanted to say time would bend, you'd have to be able to make a coherent.
Okay. Well, let's imagine that. Let's imagine that what you're saying is actually true, and see what that looks like, and see if it makes any sense. So if what you are saying is true, we're going to have. It actually reminds me of the concept of a magic sigil in a way. You have like an equation on the board, okay? And all the previous equations were just symbols relating more symbols, right?
Yep.
But when you look at this particular equation, and maybe not even just look at it, but you conceive of it, like you conceive of its meaning, then all of a sudden, it actually produces the sensation of qualia, of the sensation of blue in your mind.
No, I would not. I would not make that argument. That's not the argument I'm making. So I'm saying, like, you can, if you take this is where my CD and the sound example comes in. You can take the sound example and you can break it down and describe it in terms of ones and zeros, but the sound is never going to be in the ones and zeros. You're not going to find the sound in the programming anywhere. It doesn't exist. The sound is a fundamentally different thing than the ones and zeros on the CD that produce it, but that doesn't mean it can't be produced by the ones and zeros. You just need some way of translating.
But if that's the case, though, then if that's the case, you can translate. I mean, we can already translate, like, I mean, you saw that one experiment, I think, where they were able to tell what a person was thinking by their brainwaves, right?
Oh yeah,
They
the one
translated the
7 seconds to the head where they use the fMRI to say the press the one button or the other button.
yeah. And the reason they were able to do that, of course, is because they knew how the brain was rendering stuff, and they could, digitize it and all that. Well, that's nice, but it's not. That's because they understood how the brain works and how it generates the image, right?
Right. So that has
So
nothing to do with the question at hand because we're talking about consciousness, and you'd have to go
that
to.
involved a bit of okay. That involved a bit of imposition of in first person interpretation on there. And the point that I'm making is you can do that already with any solution that we already have.
Right, but that has nothing to do with consciousness because all they're doing is reading the subconscious mind. The subconscious mind made the decisions before the conscious mind was aware of it, which is how they could predict it would happen. So in my example, I'm saying we're going to have to create some new kind of way, some new kind of translation device to be able to translate conscious first person experience into a third person description, which we don't have yet, just like we would need to do the same thing for music, sound to ones and zeros. We do not have that yet. Not even none of the current systems can do that. The current systems just describe subconscious interactions.
What I'm getting at, if that's all we can do, though, then we're never going to solve the hard problem.
Well, no, because we can
It's simply
solve the
going to be the
sound
same.
problem. We can solve the sound problem by sound.
We can take right, but that didn't really solve. That was, I mean, that doesn't because the sound problem really is, if you think about it, a version of the hard problem. I mean, because auditory qualia are a form of first person consciousness, right?
Well, no. So I'm just saying
So if what
we
you're
take out
saying is true, then we
consciousness.
actually have solved at least one case.
Well, I'm not saying. So let's just say because sound and ones and zeros are fundamentally different. Like if we look at that as the same thing as the hard problem, we can solve that. We can say that the sound is a result of the electrical process going through the speakers, creating the vibration in the airwaves through the electrical wires produced by the ones and zeros in the specific pattern. We can solve that problem. That's not a problem at all. The problem is that we don't know how to do it with consciousness, because we need to use consciousness to get it. It's like you said, it's an epistemic problem. Because we can't solve consciousness without consciousness, we can never be certain, just like I can't be certain that you're not a pea zombie. But that isn't a problem that says we couldn't potentially come up with the correct answer. We can still come up with the correct answer, we just can't be certain it's correct. Like I can say that you're a conscious person, but I can't be absolutely certain about that because I can't experience your consciousness. You could be a pea zombie, and I can't prove that false, but I'm still going to say you're a person. Now, that's the fallibilism position in philosophy, whereas I have a justified belief that you are a person. And that is true knowledge if it's true that you're a person. So, in the same sense, I can say we're going to come up with a third person description of consciousness, and that could be true. We just won't be able to know it with absolute certainty. But it could still be true. It's not saying it's impossible for it to be true simply because we can't translate it into first person experience.
What I'm getting at, though, if that's the case, though, then you could have this ultimate completed science. Say Mary the color scientist's version of science, right? And you'd have that complete description, but you could never really know if it's like what good is that really? I mean, technically, you could say it quote unquote solved the hard problem because now you have a reasonable reason to believe that the person who is having his brain in this particular arrangement has, with these particular physical principles, has this particular first person perception, but you never really bridge the gap between third person and first person.
Right, we'd never be able to
Because
do
you
that.
are fallible.
It would be the same thing as any kind of scientific theory. We'd have to be able to use it to make some kind of new predictions or new testable things, and even though we can't be absolutely certain it's
Right.
correct.
So that's what I'm getting at. It's not really. Okay, if insofar as we can make a reasonable guess that so and so is experiencing such and such perception by having such and such brain patterns, then by that standard we have already quote unquote solved the hard problem by those tests where they could know what the person was getting, an image of what the person was thinking by having the perception of their the brain scan, right?
Well, no, because that only addresses the subconscious. It does not address the conscious mind.
There was one where they did the conscious mind as well. They had like an image. The person was conceiving of an image, or actually looking at an image, and they scanned the brain, and they took the brain waves, and they got out they got an image of what the person was looking. It it was kind of a blurry image, but you could see that it was definitely the image the person was conceiving of with the brain scan.
Right, but
It
again,
produced a blurry thinking.
there's the distinction there is that they were looking at the visual cortex, and the visual cortex, in order to make it a conscious experience, we don't know whether it like essentially goes to the thalamus and coalesces into the brain that way, or if it's a systematic process with Vanad Menon, his theory about how consciousness is processed by the brain. We don't know how the consciousness is processed. We do know how the subconscious is processed. So we can look at the visual cortex and say the subconscious is producing this visual image, and that visual image is going to be translated to consciousness, but they're not reading the consciousness, they're reading the subconsciousness. So like I can know you're feeling pain by looking at the impact on the cortical system and the limbic system, but I'm not
Okay,
reading your conscious
suppose
experience.
we do. Let's suppose we do a better version of that, and we scan some other part of the brain that does not deal with the subconscious, deals with the conscious instead, and we come to the same conclusion. Okay,
Okay.
that really hasn't. Well, you could then, in a quote unquote sense, say that has quote unquote solved the hard problem, but the problem is this whole fallibilism. It doesn't really. It's only solved it in a empty kind of way, though. At that point, because you're really not actually getting the first in order to get that last step of knowing what they're seeing, you have to impose a layer of meaning on it, and that imposed layer of meaning is first person, which defeats the entire purpose of solving the hard problem, because the whole point of solving the hard problem was to get to the first person from the third person without any imposition from the first person.
Right, you're absolutely right.
You'd always bring in the first person as
Right, that's absolutely true. But it's the same thing in science, is where we say we've solved like what.
okay, well, the area underneath is defined across this x-axis in space. Very nice. It gives you nice predictions, but it doesn't. There is an issue with taking that as a fundamental reality rather than just a mathematical tool, and that issue is as follows. Space is defined by locations. Remember I mentioned the infinite space problem before?
Yep.
There is no infinite space. If you have the infinite space with nothing inside of it, you can't define the center point. You need things that have locations to have space, okay?
Yep.
In quantum mechanics, though, things that have locations do not exist before you collapse them. And in fact, when you try and define location prior to collapse, location is actually spread out all over the place. Location of an electron is spread out between two slits, and there's a small percentage of it on the moon somewhere,
Yep.
or in Minnesota, for example. So it's smeared out all over the place. There is no location before collapse. And if there is no location before collapse, there is no space before collapse either. And so even if it's some quantum field in some other universe, then you still have this issue of that space can't fundamentally exist.
No, because that only applies to our space. It's only our space that can't exist prior to the collapse. It could still other space.
I'm talking fundamentally. If there's this quantum field, if there's a probabilistic quantum field that exists in their space that our universe came out of as there was a quantum fluctuation in that universe's 0-point field, right?
Right.
That's the theory, and that caused our Big Bang somehow. Well, what I'm getting is that previous quantum field, it still obeys the Schrodinger equation. I showed recently that the Schrodinger equation and the Heisenberg uncertainty principle are two sides of the same coin. I think you might have seen that. And of course, the 0-point field is simply the Heisenberg uncertainty principle applied to the vacuum state. So what you have here then is this. The Schrodinger equation is still defining the properties of that vacuum state in that previous universe. And if that's the case, then that space shouldn't really fundamentally exist because none of the locations are defined before collapse.
Right. In emergent
so
space.
It's not really a problem of going to the previous universe, on and so forth. What it's a problem of is this notion of space existing as a real thing is not really compatible with what the quantum equations are doing.
Well, no, that only applies to our known kinds of space and time. There could be some more fundamental space-time where it does have a stronger existing position.
It's not an issue. It's not an issue of. It's not an issue of the space, like some kind of different space. So, like maybe it doesn't even have Minkowski space, or maybe it has, just good old Euclidean space, right?
Well,
or maybe
I'd
some
say
other
like
kind of
the
space
Heisenberg uncertainty
right?
principle.
Well, the issue is that whatever you have, space is mathematically defined as having an ability to distinguish between two locations, right? Doesn't really mean anything to talk about space if you can't distinguish between locations.
Well, no, that's the point. Is that the Heisenberg uncertainty principle, where we can't know
Now,
when
if that's the
motion.
case,
No, that only applies to
then
our space. That only applies to our known kind of space. It does not apply to all possible spaces.
well, you can do what you can do is you can come up with, and this is actually what they do in a sense. They call it Hilbert space, okay? But Hilbert space is not a space in the way that we think of physical space, okay?
Right. I'm not referring to Hilbert space here. I'm saying that
it's a different domain of reality. Not
there could be other kinds
okay.
of space entirely, like the Itzelbar's two-time physics. There could be two space physics, or so there could be the limitations of our space.
That's what they're saying, though. That's what they're saying. In fact, he's got a blog. Carol has a blog, Space from Hilbert Space.
Right. No, but this is my argument. This is my argument. I'm saying that the Heisenberg uncertainty principle and the Schrodinger equation only apply to our known kinds of space. So even though our known kinds of space are contradictory with the idea of an existent kind of space, that does not mean there can't be a different kind of space prior to ours.
Okay. Let me adopt you on that. Let me adopt you on that, okay? Let me just take that on board for a second, and this is actually kind of cool because this will give me an opportunity to show my model off.
All right.
Let me assume that there is, in fact, some other kind of space beneath. And maybe we can even say that is Hilbert space. Because Hilbert space is not spatial in the way that we think of space. It doesn't have locations that are distinct from each other, right? Maybe you're saying, okay, very well, maybe there is some other kind of space. The thing with this is now, what's your favorite kind of ice cream?
Chocolate.
Right. I mean, you'll see where this is going in a second. What's your second favorite kind?
Cherry.
Okay, so you go to the freezer door, and there is chocolate and cherry in there. Now, if you're a classical computer, you should pick one or the other very instantly, like the Terminator. Just program out your choices. You process for a split second. You pick one. You close the freezer door. But you don't actually do that in real life, do you? I mean, not often. You sometimes will go there and you'll kind of waffle. Do I want chocolate or do I want cherry? And you can't really decide. And then you finally do decide a couple seconds later, and then it goes to either one or the other rather than both.
Right.
What does that sound like to you?
Like a computer.
Where does something be both one and the other at the same time until then it's only one?
Well, no, it just sounds like a slow processor. It doesn't sound like anything special.
Well, it sounds like quantum superposition. The cat is both dead and alive at the same time, and then it's one or the other, right?
Well, no, because when you're trying to decide between
the reason this started was they were noticing. Your audio broke up for a second.
I paused. So when we're deciding between ice creams, it sounds more like the slow processor. If the Terminator takes like 5 seconds to decide an ice cream, just do the processing and leave. The human brain is just a bigger, more complicated processor.
Sometimes it goes back and forth, though. Like you process one thing, and then all of a sudden you change your mind. And now what's interesting is there is actually a field, and this is actually consensus. That being said, they haven't gotten the full way and said, therefore, it's quantum. But they do say that it behaves quantum. And this actually started with something called quantum economics, where they recognize that stock market behavior could be modeled by the Schrodinger equation. Like, this is the weirdest thing in the world why this is. And they thought, well, really, what is stock market trade, right? There's people on the floor that are buying shares. And what are they doing? They're making human decision-making processes based partially on fuzzy logic and so on. So what they did is they realized, well, maybe this isn't just an economics thing. Maybe this is a human psychology thing. And they started this study on this, and they have this whole field now called quantum cognition. And it's actually been discovered that human behavior, decision-making behavior, it can actually be accurately modeled by quantum mathematics. And they further have some evidence for this, that it's not just like a mathematical modeling, because you can say, well, it's just a mathematical modeling, doesn't mean it really is this way. They have a lithium, there's a guy named Matthew Fisher who was studying this, and there was an experiment done where you have rats that are given there's a control group, there's 3 groups of control group, there's one group that's given lithium-7, an isotope, and there's one that's given the traditional lithium-6. Now, it turns out that the rats that are given the lithium 6 display vastly stronger maternal instincts than both the ones that have the control group and the lithium 6 isotope. So lithium 7 will make them much stronger maternal instincts than the other ones. Okay.
Okay.
Now, what's interesting about this is lithium 6 and 7 are chemically identical. There are no chemical properties that distinguish the two, right?
Yep.
It's the same valence electron, interact with the same, they bond with the same atoms, do all the same things, right?
Yeah.
So what's interesting, the only thing that's different at all of this is the Hamiltonian, the energy value, which is, you plug that in the Schrodinger equation, it gives you back a different wave function. And so it's interesting here because what changed the rat's cognitive behavior in maternal instincts was purely a quantum mechanical phenomenon. It's quantum biology at work. And no, he thinks that this is the case in humans, with something called the Posner molecule, which is the phosphate ions that get entangled and they break down. And because of how they interact with like nitrogen and oxygen atoms, what happens is that it preserves the decoherence in the isotope or the phosphate molecule for a very long period of time, like on the orders of hours or days, which is more than enough for human processing. So it's actually very interesting now because we have this direct link to saying that Hilbert's the mind is actually in the wave function,
Well, wait,
and this could be
made
very
you
directly
skip there.
connected to
So
quantum biology
the
in the
mind
brain.
can be affected by things with the wave function, but that doesn't mean the mind is a part of the wave function. Well, everything's a part of the wave function, but that doesn't mean that the mind is fundamentally synonymous with the wave function.
It's a good reason. Okay, what I'm saying is it's a good reason to believe that the mind is not part of the classical collapsed world, but is actually part of that. What the mental processes going on are not part of a. You have the collapsed world after the wave function collapse, and that produces this. You can make classical computers out of that, and so on. What it's saying is that the mind is essentially a quantum computer.
Well, no, because the lithium that doesn't preclude the lithium from collapsing and causing the change after the collapse. So that wouldn't mean that it was pre-collapse mind. Why would you come to that conclusion?
Well, no, because the lithium's already collapsed in that sense. I mean, if you're going to do that, they collapse the same way. The lithium 6 and lithium 7, they're going to interact with the surrounding environment the same way.
Not after the collapse. That's why they're different. That's what makes them lithium 6 and lithium 7 are
They're
different.
different. They're different. What makes them different is their quantum properties.
Right.
They have a different energy value. That's it, and that gives different. All their chemical. I mean, maybe you could say it gives them a little more kinetic energy, but in terms of like neurology, they're not really looking at the kinetic energy in terms of neurology is a very small. I mean, it's kind of akin to like how gravity. Talk about like say detecting neutrinos or detecting subatomic particles. Yes, there's like gravity that could interact by, but particle physicists neglect that because it's so small at that level that it's not going to change the experiments much.
Well, right, but
Anything at all,
that's
really.
the point is that
It's so small as to be negligible, and so it's the same thing here.
the cause could be pre-collapse or post-collapse in this case. We don't know. We know that the case may be small post-collapse, but it doesn't mean that the case is going to be bigger
Okay,
pre-collapse.
so what I'm getting at here, okay, so you can debate that if you want. Okay, that's fine, but what I'm getting at is, let's suppose that it is found that this Posner molecule is what is mediating consciousness, and that the conscious thought processes are occurring in superposition. Okay,
Okay.
if that's the case, then it would follow that thought processes are occurring in Hilbert space, which is the beneath emergent spacetime level of reality. And so then we would have this very interesting situation of it would actually fit very well with certain things that about consciousness, such as where are ideas located or platonic forms. They're not located. You can open your brain up, and I'm not going to see the number 2 floating around your synapses, right? I'm going to see processes correlated to it, but I won't see the number 2 itself.
Right.
And then you ask, well, where is the number 2? Is it in your car? Is it behind your sofa? Well, that doesn't make sense. And the reason it doesn't make sense is, well, that ideas are outside of space and time in this sort of platonic sense, right?
No.
Plato's concept of the.
So in the understanding of most materialists, ideas are just combinations of chemical processes in the brains. They are actually in space and time. They're just abstract definitions of those things. So just like a
Okay,
sound wave.
okay, you don't believe that. You don't believe that. I know. You don't believe that, but what I'm saying is you can very directly conceive of what I'm talking about, right? Even though you don't agree with it,
Sure.
because it's not something that is completely foreign to your sensibilities, your conception of what reality is.
Sure.
So what's very fascinating about this is you have this Plato's rule of forms that is outside space-time. And what's weird now, though, is that if this is the case, you model consciousness is occurring in Hilbert space, and Hilbert space is, well, that's where the ideas are located, basically. They are the quantum information that you are processing right now. But then you ask, well, put the Hilbert space into the quantum gravity. What happens? Well, that means it's also, quote unquote, outside space-time, isn't it?
Well, yeah.
And so there's your pre-space before the Big Bang. It's Plato's world. It's a shared inner space.
Well, no, you wouldn't. That
And
wouldn't
so
be
that's my
the.
model, is that there.
Oh, that's your model. Okay. Because yeah, Sean Carroll's model wouldn't agree with that. It does say the
The
Hilbert
giant
space.
cognitive inner.
Yeah. Okay.
I know he would flip up at this. I know he would. Actually asked him once about the integrated information theory, and he simply said, "I don't know enough about IET to say." But it was after that about a year later, he didn't know anything about it, and then about a year later, he came out trying to blast IET, and I think I know why, because it. I pointed out that if you combine IET with his own physics, it gives you idealism. Now, what's funny about this case, you would actually have a space that is not spatial in the sense that we think of space, right? Of distinguishing between locations, right?
Right.
Which fits your concept of what a space is, what it could be. And you then have it outside of space-time, and it generates our space. But the weird thing about this is if you think about what this space, quote-unquote, would actually be like, well, there's your own conscious experience, but then if all the rest of it's mental as well, and it's not in part of your consciousness, but it influences your consciousness, it's subconscious, which in a way it's a kind of a scientific translation into Carl Jung's notion of a collective subconscious.
What? Because I'm not following what you're saying.
So there in a kind of plain way, you have a completely. What I'm saying is you have space-time essentially emerging from a collective unconscious that is described in completely physicalist terms through quantum cognition. And so there, in a goofy way, you can kind of both win. You have your quote-unquote materialist description of reality, and that everything is empirically connected, and yet at the same time, it is the space, the quote-unquote material space that you're describing it coming from is actually a mental space. It's a giant inner space, and the whole thing is being simulated inside of it.
Well, I mean that doesn't follow because even if we grant your idea that mind is a part of this lithium non-collapsed Hilbert space, and then you would also think that the Hilbert space is pre-space time. That doesn't mean that those are the two synonymous things. Like the mind kind of Hilbert space
Well,
could be.
I told you it was hypothetical. I told you it was
Okay.
hypothetical. I
Okay.
was giving you this. I mean, there's good reasons
Okay.
to believe that it is on other grounds as well. Feynman universal simulator. But we were exploring this as a thought experiment. Okay.
All right. Fair enough.
So I was giving you an example of showing you of how what you're calling materialism and what I'm calling idealism, they don't have to necessarily. We start out defining them as as opposed to each other. What I'm saying is, when we break them down sufficiently, we can discover these situations where there really isn't anything other than definitions that are making them contradictory to each other. The actual substance of them is such that they could be equivalently describing the exact same thing and being equivalent.
All right. I'm not sure. I
What
haven't.
do you think of that? Is
I'd have
that
to.
interesting?
Yeah, I'd have to take a lot of time to really think about that before I can really say I'd understand what you were saying there. But it's an interesting idea. But anyway, it's getting late. I need some food, and it was really great talking to you.
Kind of blurs the line between. All right, I'll let you go.
Yeah. All right. Well, we should talk again sometime. I really enjoyed it. Thanks for coming on.
I had a different argument that I wanted to do, but yeah, maybe later.
Absolutely.
All right, definitely. I'm going to share this on my channel too, if you don't mind.
Oh,
So.
please. Absolutely. I love more exposure, the better.
All right,
See ya.
see ya.